Picture an object pulled from the depths of the sea, encrusted with the residue of 2,000 years. It's a lump of corroded bronze and wood, seemingly unremarkable until experts begin to piece it together. What they reveal is nothing short of an ancient computer, a complex clockwork of gears and dials that could predict the movements of the sun, the moon, and the planets with stunning accuracy. This is the Antikythera Mechanism, a device so advanced that nothing like it would appear again for over a millennium. It feels like it doesn't belong in its own time, a ghost from a future that never was, left behind in the ancient world. And it forces us to ask a single, haunting question. If they could create this, what else did they know that we have since forgotten? This is the world of lost technologies, the incredible inventions and sophisticated knowledge of ancient civilizations that vanished from history, only to be rediscovered centuries or even millennia later. We often picture the past as a linear march of progress, a story where we started with simple tools and gradually built toward the complex world we live in today. But that story is incomplete. Scattered across the globe, buried in the earth, and hidden in plain sight within ancient texts are the remnants of a different narrative. These are the technologies that challenge our very perception of history, suggesting that our ancestors reached peaks of understanding that were then lost to time, waiting to be found again. They are not myths or legends, they are physical evidence, artifacts that force us to reconsider what we think we know about human ingenuity. In this video, we are embarking on a journey to uncover 35 of these mind-boggling marvels. We will explore everything from a Roman concrete so durable that it has survived 2,000 years of pounding ocean waves while our modern versions crumble after decades, to mysterious clay jars from Baghdad that some believe functioned as ancient electric batteries. Each one of these discoveries is a puzzle piece, pointing to a level of sophistication we rarely attribute to the ancients. This exploration is more than just a list of curiosities. It is an invitation to look at history with fresh eyes, to feel a sense of wonder at the sheer ambition and brilliance of those who came before us. So, join us as we dive into the secrets of the past and prepare to be amazed by the lost technologies that prove our history is far more mysterious and extraordinary than we ever imagined. Our journey through the annals of lost technology begins not with a complex machine, but with something seemingly mundane, a simple mixture of rock, water, and ash. Yet, this humble material allowed the Romans to build an empire that literally stood the test of time. While many of our modern concrete structures require constant repair and are often crumbling after just 50 years, Roman piers and breakwaters have been submerged in the Mediterranean Sea for 2 millennia, enduring the relentless pounding of saltwater waves. They haven't just survived, in many cases they have grown stronger. The secret to this seemingly impossible durability lies in a revolutionary recipe that was lost for centuries, only now being unlocked by advanced scientific tools. The cornerstone of this ancient marvel was a special volcanic ash known as pozzolana, named after the town of Pozzuoli near Mount Vesuvius where it was first quarried. The Romans, brilliant empirical chemists, discovered that when this specific ash was mixed with lime and seawater, it triggered an extraordinary chemical reaction. Unlike modern Portland cement, which is inert once it sets, Roman concrete is a living material. When seawater percolates through its microscopic cracks, it interacts with the pozzolana, ash, and lime to form rare, crystalline minerals like altobermorite and philipsite. These minerals effectively fill the cracks, healing the concrete from the inside out. It's a self-repairing system, a technology we are only just beginning to master with smart materials in the 21st century. A perfect testament to this engineering genius is the Pantheon in Rome. Its magnificent dome, still the world's largest unreinforced concrete dome nearly 2,000 years after it was built, stands as an open challenge to our modern construction methods. It has weathered earthquakes, invasions, and the elements without a single steel rebar for support. Compare this to countless modern bridges, parking garages, and buildings that show significant decay within a human lifetime, requiring vast sums of money and resources to maintain. The Roman approach was not just different, it was fundamentally more resilient and, ironically, far more sustainable. Today, teams of geologists and engineers are using powerful electron microscopes and X-ray technologies to reverse engineer the Roman formula. The goal is not merely to mimic it, but to understand the precise chemical pathways that lead to its self-healing properties. The implications for our world are profound. Imagine constructing seawalls that grow stronger with climate change-induced rising seas, or building foundations that require no repairs over their entire lifespan, drastically reducing the carbon footprint of the construction industry. The quest to rediscover this lost technology is more than an academic curiosity. It is a race to reclaim a level of wisdom that could help us build a more durable and sustainable future, learning a vital lesson from the ancient past. From the enduring strength of Roman concrete, we turn now to a technology designed not for creation, but for pure, unadulterated destruction, a weapon so fearsome that its very name became synonymous with divine wrath. Imagine you are a sailor in the 7th century, part of a vast fleet besieging the magnificent city of Constantinople. From the walls of the city, you see the Byzantine Droman warships approach, not with battering rams, but with strange, tube-like bronze pumps mounted on their prows. Suddenly, a stream of liquid fire erupts from these tubes, arcing through the air. It strikes the water around your ship, and instead of being extinguished, the sea itself seems to ignite. Flames cling to the wooden hull, impossible to douse with water, which only seems to make the inferno burn brighter. This was the reality of Greek fire, the Byzantine Empire's ultimate secret weapon. Its strategic value cannot be overstated. At a time when the survival of the Eastern Roman Empire hung by a thread, Greek fire was the decisive factor that saved Constantinople on multiple occasions, most famously during the Arab sieges of the 7th and 8th centuries. In naval combat, it was utterly devastating. Enemy ships packed with warriors and combustible materials were transformed into floating infernos in a matter of minutes. The psychological impact was as potent as the physical one. To opposing forces, this was not a natural fire. It was a hellish substance that defied the elements, leading many to believe the Byzantines commanded the very fires of heaven or hell. This perception was a powerful deterrent, a form of psychological warfare that protected the empire for centuries. The secret of Greek fire's composition was arguably more valuable than any single treasury. Its recipe was a state secret of the highest order, known only to a select few, likely the reigning emperor and a single family of chemists. The secrecy was so extreme that the method of its manufacture and deployment died with the empire itself. We are left with tantalizing clues from historical accounts, which describe a liquid that was projected through a pressurized pump called a siphon, often accompanied by a loud roar and great clouds of smoke. The primary ingredient was almost certainly a form of crude oil or naphtha, which is naturally flammable. But the mystery lies in the additives that gave Greek fire its unique, terrifying properties. Theories about these secret components abound. Quicklime was a likely candidate, as it ignites upon contact with water, explaining why the flames seemed to intensify when sailors tried to douse them. Others suggest additions like saltpeter, pine resin, or various forms of sulfur to create a sticky, napalm-like substance that would cling relentlessly to its targets. Some even speculate about more exotic ingredients, perhaps certain chemicals that created a form of spontaneous combustion. The truth is, modern science can recreate a substance with similar properties, but we cannot say with certainty that we have replicated the exact formula used by the Byzantines. The precise combination and the engineering of the pressurized delivery system remain one of history's most enduring chemical mysteries. It stands as a powerful example of how a technology protected by absolute secrecy can be lost forever, leaving behind only legends and the echoes of its terrifying power. While Greek fire harnessed the raw power of chemistry, the next lost technology on our list represents a breathtaking leap into the realm of precision mechanics and abstract thought. For decades after its discovery, the Antikythera Mechanism was dismissed as a curious but ultimately unremarkable artifact, a corroded lump of bronze and wood recovered from an ancient Roman shipwreck off the coast of the Greek island of Antikythera. It wasn't until the advent of advanced imaging technology like X-ray and CT scanning that researchers could see past 2 millennia of seabed incrustation. What they revealed was nothing short of revolutionary, an intricate clockwork device consisting of at least 30 precise, interlocking bronze gears housed in a wooden case no larger than a shoebox. This was not a simple navigational tool or a toy. It was a sophisticated mechanical computer, a device of such complexity that it single-handedly rewrote the history of technology. The primary purpose of this ancient marvel was to model the cosmos. By turning a hand crank on the side of the device, the user could set a specific date, and the gears would work in concert to display the positions of the Sun, the Moon, and likely the 5 known planets Mercury, Venus, Mars, Jupiter, and Saturn across the zodiac. But its functions went far beyond simple planetary positions. Detailed inscriptions on the mechanism's front and back dials served as a kind of user manual, explaining how to read predictions for solar and lunar eclipses. It even tracked the 4-year cycle of the ancient Olympic Games, integrating celestial events with the most important social and cultural calendar in the Greek world. In essence, it was a portable orrery, an astronomical predictor, and a complex calendar all rolled into one, a physical manifestation of Greek mathematical and philosophical understanding. The engineering sophistication required to create such a device is staggering. The gears are not simple spur gears. They include sophisticated differential gearing and pin and slot mechanisms that allowed the mechanism to account for the irregular, elliptical orbits of celestial bodies, particularly the Moon. This level of mechanical insight was thought to have been first invented in the 16th century for automobile differentials, yet here it was, fully realized in the 1st or 2nd century before the Common Era. The miniaturization of these components, some with teeth cut to tolerances of a fraction of a millimeter, suggests a workshop tradition dedicated to precision metalworking that is entirely absent from the rest of the archaeological record. It implies the existence of a lineage of master craftsmen and scientists whose names are lost to us, but whose genius is preserved in this one surviving machine. This single artifact forces a complete re-evaluation of what we thought we knew about ancient Greek technological capabilities. We have no other devices like it from that period, not because it was unique, but likely because it was part of a technological tradition that was almost entirely lost. The knowledge required to design and build the Antikythera Mechanism, a deep understanding of astronomy, advanced mathematics, and precision engineering simply vanished from the historical narrative for over 1,000 years. Nothing of comparable mechanical complexity would appear again until the astronomical clocks of medieval Europe in the 14th century. The mechanism stands as a haunting testament to a path not taken, a peak of ancient scientific ingenuity that collapsed along with the classical world, leaving behind a silent, corroded ghost that whispers of a forgotten age of mechanical wonders. Moving from the intricate gears of the Antikythera Mechanism, we now turn to a technology that represents the pinnacle of ancient material science, a substance renowned not for its complexity but for its sublime and deadly perfection. This is the story of Damascus steel, a legendary metal whose name has become synonymous with blades of almost supernatural sharpness and strength. The very word Damascus evokes images of crusading knights, their own swords shattering against the shimmering, water-patterned blades of Saracen warriors. But the true origin of this wonder steel lies not in Syria, but much further east in the furnaces of ancient India. There, metalworkers developed a method for creating what was known as wood steel, a high-carbon crucible steel characterized by its distinctive banding pattern. The process began with a specific type of iron ore, rich in trace impurities like vanadium and molybdenum, found only in certain mines in the Deccan Plateau. This raw material was combined with charcoal and sealed inside a clay crucible, then heated for days at a controlled temperature. The result was a solid ingot of steel, itself a masterpiece, which was then traded along ancient routes to smiths in Damascus and other centers of the Islamic world. It was these master craftsmen who perfected the final, crucial step, transforming the raw ingot into a blade of mythic quality. The forging process was an art form passed down through generations. The Wootz ingot was heated to a precise, bright yellow-orange heat, not white-hot, which would destroy its delicate crystalline structure, and then painstakingly hammered and folded. This wasn't the repeated folding of Japanese swordsmiths. It was a more subtle process designed to draw out the blade without breaking the internal pattern. The true magic, however, lay in the cooling. The smiths employed a unique and mysterious temperature control technique, likely involving a gradual cooling cycle within a specific medium, perhaps hot ashes or sand. This slow, controlled descent in temperature allowed the carbon within the steel to form into microscopic structures known as cementite or iron carbide, which arranged themselves in the swirling bands that gave the steel its beautiful signature appearance. The performance of a true Damascus blade was what truly set it apart. Historical accounts describe blades so sharp and resilient they could slice a silk scarf floating in the air and cleave through a rifle barrel without losing their edge. This legendary toughness came from a perfect marriage of properties: a hard, razor-sharp edge made possible by the high carbon content, combined with a remarkably flexible and shock-absorbent core that prevented the blade from chipping or breaking in combat. It was a combination that European swordsmiths of the era could not replicate, making these weapons the most feared and coveted of their time. So, what happened to this extraordinary knowledge? The decline was a perfect storm of historical and geological factors. The primary source, the specialized iron ore mines in India, were eventually depleted. As the raw material became scarce, the art of producing Wootz steel ingots faded. Concurrently, the political and social upheavals in the Middle East disrupted the guilds and family lineages of smiths who held the secrets of the final forging and cooling processes. By the end of the 18th century, the knowledge was effectively lost, leaving behind only the legendary blades themselves as silent witnesses to a forgotten art. For over 200 years, modern metallurgists have been attempting to reverse engineer Damascus steel with only partial success. We can create steel with a similar visual pattern, but replicating the exact combination of sharpness, strength, and flexibility has proven elusive. The most fascinating modern theory involves nanotechnology. When samples of authentic Damascus steel are examined under powerful electron microscopes, some researchers have found evidence of carbon nanotubes, incredibly strong, microscopic cylindrical structures of carbon within the steel's matrix. It's a startling possibility that ancient smiths, through their empirical mastery of temperature and composition, were unknowingly creating a nanocomposite material over 1,000 years before the term was even invented. This suggests their craft was not just an art but a form of high-level materials science, a technology so advanced that we are still striving to catch up to the masters of the past. While the Antikythera Mechanism and Damascus steel represent pinnacles of material and mechanical engineering, our next lost technology is a testament to something equally profound: the human capacity to internalize the rhythms of the natural world. Imagine setting out across the largest ocean on Earth in an open canoe, with no compass, no maps, and no sextant. For centuries, this was the reality for Polynesian voyagers, who embarked on journeys of discovery that make the voyages of European explorers look like coastal day trips. They settled a vast triangle of islands stretching from Hawaii in the north to Easter Island in the east, and all the way to New Zealand in the southwest, a geographic area larger than the entire continental United States. Their achievement stands as one of the greatest feats of exploration and navigation in human history, all accomplished through a sophisticated science of wayfinding that was nearly erased by colonial influence. The foundation of this science was a deep, experiential knowledge passed down through generations of master navigators. These individuals, known as PWO in some cultures, were not simply sailors, they were living libraries of environmental data. Their primary tool was the star compass, a mental construct that divided the horizon into 32 directional houses, each marked by the rising and setting points of specific stars and constellations. As one star set, the navigator would already have the next one rising in a different house fixed in their mind, creating a celestial roadmap across the night sky. But this was only the beginning of their navigational toolkit. During the day or when clouds obscured the stars, they relied on a second, equally complex language, the ocean itself. They learned to read the subtle patterns of ocean swells, the large, rolling waves generated by distant weather systems. A master navigator could lie down in the canoe and feel, through the vessel's motion, the direction of as many as 4 different swells interacting. By maintaining alignment with these constant, deep ocean rhythms, they could hold a steady course even without visual cues. They also became expert interpreters of other natural signs. The specific flight paths of birds at dusk could indicate the direction of land, as certain species would fly out to sea to fish during the day and return to their nests at night. Even the colors and types of clouds on the horizon offered clues. A stationary, greenish tint under a cloud might suggest it was reflecting the lagoon of an atoll still far beyond the visible horizon. This incredible knowledge was applied from the decks of vessels that were marvels of maritime engineering in their own right, the double-hulled canoes or wa. These were not simple dugout canoes, they were massive, ocean-going ships often exceeding 60 feet in length. 2 narrow hulls carved from massive logs were connected by strong wooden crossbeams and topped with a central platform that could carry dozens of people, along with plants, animals, and supplies for voyages that could last for weeks. The design provided exceptional stability and speed, capable of sailing efficiently against the wind thanks to a lateen or crabclaw sail made of woven pandanus leaves. These vessels were the spaceships of their era, enabling the intentional exploration and colonization of the most remote islands on the planet. Tragically, this vast repository of knowledge faced near extinction with the arrival of European explorers and missionaries. As Western ships with their magnetic compasses and charts became dominant, the ancient art of wayfinding was dismissed as primitive superstition. The construction of the Great Wa declined, and the rigorous training of new navigators was suppressed or abandoned. For a time, it seemed this unique technology, a science built on memory, observation, and a profound connection to the environment, would be lost forever, surviving only in fragments of songs and stories. But in the latter half of the 20th century, a remarkable revival began, spearheaded by a few determined individuals. In Hawaii, the Polynesian Voyaging Society was founded, and in 1976, they launched the Hokulea, a replica of a traditional double-hulled voyaging canoe. The successful voyage from Hawaii to Tahiti, guided by the Micronesian master navigator Maupiailug, who still held the ancient knowledge, proved to a new generation that their ancestors' feats were not accidental drifts, but acts of brilliant, intentional exploration. This voyage ignited a cultural renaissance across Polynesia. Today, a new generation of navigators is being trained, and canoes like the Hokulea continue to sail the globe, not just as cultural symbols, but as working proof of a technology that allows humans to navigate the greatest wilderness on Earth using nothing but the wisdom of the past written in the stars, the waves, and the wind. Now consider an object that seems to defy the very timeline of scientific progress, an artifact so seemingly simple that its potential function sparks debate to this day. In the basement of the National Museum of Iraq in Baghdad sits a small, unassuming clay jar, roughly the size of a man's fist. It dates back to the Parthian period, sometime between 250 years before the Common Era and 225 years after. But it is not the jar itself that is remarkable, it is what was found inside. The jar contained a rolled-up copper sheet forming a cylinder which housed a single iron rod. Both the rod and the cylinder were held in place with an asphalt plug, which also acted as a seal. To the untrained eye, it appears to be a peculiar but mundane storage container. However, to German archaeologist Wilhelm Koenig, who studied it in the 1930s, it bore a striking resemblance to something that should not have existed for another 2,000 years, an electric battery. The theory is compellingly straightforward. If this jar were filled with an acidic electrolyte liquid such as vinegar or wine, a chemical reaction would occur. The acidic solution would interact with the two different metals, the copper cylinder and the iron rod, creating a potential difference in voltage between them. In essence, this setup would constitute a primitive galvanic cell, capable of producing a small but measurable electric current, estimated to be around 1 to 2 volts. Supporting this hypothesis are the telltale signs found on the artifact itself, traces of corrosion on the iron rod that are consistent with the effects of an acidic agent. Proponents of the battery theory ask a simple question: why would such a specific combination of materials, sealed so carefully, be created if not to generate electricity? If it was indeed a battery, the next natural question is, what would it have been used for? One of the most cited and practical applications is electroplating, the process of using an electric current to deposit a thin layer of one metal onto the surface of another. The ancient Mesopotamians were master goldsmiths, and we know they developed a technique for gliding silver objects with a thin layer of gold, a process known as fire gilding, which involved the use of toxic mercury. Could a simpler, safer method have existed? A series of these Baghdad batteries, connected together to create a higher voltage, could have provided enough current to electroplate a small object like a ring or a pendant with gold. Another theory, though more speculative, suggests a medical application. Ancient Greek and Roman texts describe the use of electric fish to administer shocks for pain relief. It is conceivable that a healer or priest might have used a weak current from such a device to create a tingling sensation, perhaps for a form of early electrotherapy or to enhance the mystique of a religious ritual. However, the academic world is far from unanimous in accepting this electrifying interpretation. Skeptics offer a much more conventional explanation. The object is simply a storage jar for sacred scrolls. They argue that the iron rod was a placeholder and the asphalt plug was a standard seal to protect precious papyrus or parchment text from moisture and insects. The corrosion on the iron, they suggest, could have been caused by any number of environmental factors over 2 millennia. The main point of contention is the complete absence of any wires or conductors that would be necessary to complete an electrical circuit and actually use the generated current. Without such associated finds, the battery theory remains in the realm of intriguing speculation rather than proven fact. This ongoing debate is precisely what makes the Baghdad Battery so fascinating. It sits at the intersection of what we know, what we can prove, and what we can only imagine. It forces us to confront a tantalizing possibility that the principle of electrochemistry may have been stumbled upon not in the labs of Alessandro Volta in the 18th century, but in the workshops of ancient Mesopotamia. Whether it was a revolutionary power source or a humble scroll jar, the artifact embodies a profound mystery. It serves as a powerful reminder that a single, enigmatic object can challenge our entire narrative of technological evolution, leaving us to wonder if a spark of ancient genius was lost, waiting only for the right conditions to be rekindled. Leaving behind the electrochemical mysteries of Mesopotamia, we arrive at a tale that speaks not to a physical artifact, but to a ghost of a technology, one preserved only in ancient gossip and the chilling fear of economic collapse. Our sources for this story are two of Rome's most celebrated writers, Petronius and Pliny the Elder, who recount a remarkably similar anecdote about the reign of Emperor Tiberius. According to their accounts, a humble craftsman, a glassblower of extraordinary skill, gained an audience with the emperor. To demonstrate his unparalleled artistry, the man presented Tiberius with a beautiful drinking vessel crafted entirely from glass. But this was no ordinary glass. In a stunning display, the craftsman threw the vase onto the stone floor. Instead of shattering into 1,000 pieces, it merely dented like a vessel made of bronze or silver. Then, using a small hammer, the man patiently worked the dent out until the vase was restored to its original, perfect shape. He had created what the Romans called vitrum flexile, flexible glass. The emperor's reaction, however, was not one of awe-struck wonder. Tiberius, a notoriously paranoid and frugal ruler, was immediately seized by a cold, calculating dread. He asked the inventor a single, pointed question. Had he shared the secret of this unbreakable glass with anyone else? The craftsman swore he had not. Believing he had contained the knowledge, Tiberius made a ruthless decision. He ordered the man beheaded. His reasoning, as recorded by the ancient historians, was brutally pragmatic. This new material, if it became widely available, would instantly devalue the imperial reserves of gold and silver. Why would anyone treasure a silver goblet if they could own an unbreakable, repairable glass one that was just as beautiful? To protect the foundation of the Roman economy, the technology had to be eradicated before it could even begin. This story is often held up as a prime example of technological suppression, a cautionary tale about an innovation snuffed out by entrenched power. But it also raises a profound scientific question. Could such a material have actually existed? Modern materials science offers some fascinating possibilities that move this story from pure myth into the realm of the tantalizingly plausible. One strong candidate is a class of materials known as metallic glasses. Unlike conventional metals, which have a highly ordered crystalline structure, metallic glasses are created by cooling certain metal alloys so rapidly that the atoms don't have time to arrange themselves into crystals. The result is a solid material with the disordered atomic structure of a liquid, which gives it unique properties. It can be incredibly strong, corrosion-resistant, and under specific conditions of heat and pressure, can exhibit a degree of plasticity or flexibility before failing. Another possibility lies in the world of polymers, though these were far beyond the reach of ancient chemists. However, the Romans were master empiricists, constantly experimenting with natural resins, plant saps, and other organic compounds. It is not entirely impossible that a glassmaker, through a fortunate accident involving a specific additive, perhaps a colloidal substance or a natural polymer, could have created a composite material that gave ordinary glass a measure of flexibility. The description of the craftsman hammering out the dent is particularly telling. It suggests a material that was malleable when worked, not simply elastic like rubber. This points towards a metallic property rather than an organic one. The most compelling argument for the story's potential truth, however, is not a modern material but a modern parallel, the fate of ductile glass fibers. In the 20th century, scientists discovered that pristine glass fibers, drawn to a very fine diameter and completely free of surface imperfections, can be surprisingly flexible and strong. But the moment these fibers are handled and microscopic scratches appear on their surface, they become brittle again. Imagine an ancient artisan who perfected a method of creating a glass object with a perfectly flawless protective surface layer. It might have appeared flexible and unbreakable in a controlled demonstration, but been completely impractical for mass production or daily use, its secret dying with its creator. Ultimately, the mystery of flexible Roman glass remains just that, a mystery. We have no archaeological evidence to support its existence. No shard of vitrum flexile has ever been found. This leads many historians to dismiss the story as a fictional parable about hubris and imperial power. Yet, the fact that two separate, respected Roman authors recorded it independently suggests it was a circulating legend, if not an actual event. Whether fact or fable, the story encapsulates a powerful idea that the path of technology is not always one of steady progress. It can be diverted, interrupted, or even deliberately broken. The lost secret of flexible glass serves as a haunting reminder that a single invention and a single decision might have reshaped our material world in ways we can only imagine, leaving us to wonder what other wonders were lost to the fears of those in power. We now journey high into the Andes Mountains of Peru, to a site that challenges our understanding of ancient engineering, not with intricate gears or complex chemistry, but with sheer, overwhelming mass and precision. Towering over the ancient Inca capital of Cusco, the fortress of Sacsayhuamán presents a spectacle of stonework so audacious that it seems to defy the very laws of physics. Here, you are not looking at neatly cut blocks, but at a colossal jigsaw puzzle assembled from stones of staggering size and bewilderingly irregular shapes. Some of these granite boulders are colossal, weighing well over 100 tons, the equivalent of a fully loaded semi-truck, and yet they are fitted together with a joint so seamless, so impossibly tight, that even a razor blade cannot be inserted between them. This is not merely construction. It is a form of megalithic artistry achieved without the use of mortar, without the wheel, and without iron tools, leaving us with one of the most enduring architectural mysteries in the world. The process begins with a question that has baffled engineers for centuries. How did the Inca, with a technology base limited to stone, bronze, and copper, even quarry such monoliths? The granite for Sacsayhuamán was sourced from quarries located several miles away, up steep and rugged mountain slopes. The prevailing theory suggests that workers used a combination of precise stone hammers to fracture the bedrock along natural fault lines and then employed wooden wedges. These wedges would be inserted into cracks and then soaked with water. As the wood expanded, it would generate tremendous pressure, slowly and deliberately splitting the stone into manageable, though still gargantuan blocks. But quarrying was only the first and perhaps the simplest part of the challenge. The real enigma lies in the transportation. How do you move a 100-ton stone over miles of mountainous terrain without wheels, without draft animals stronger than the llama, and without complex pulley systems? The most widely accepted explanation involves an immense investment of human labor. It is thought that thousands of workers would maneuver the stones using a system of ropes, levers, and earthen ramps. They might have placed the boulders on log rollers, painstakingly pulling them along, with teams constantly moving logs from the back to the front in a continuous cycle. Some researchers propose that the stones could have been dragged on sledges across wet clay to reduce friction. While these methods are plausible, the sheer scale and elevation gain involved make the feat almost unimaginable, a testament to the incredible organizational power and sheer determination of the Inca state. Yet, the most perplexing stage of all is the final fitting. How were these irregular, polygonal stones shaped to interlock with such insane precision? The conventional view is that stonemasons used harder stone hammers to pound the surfaces into shape, then painstakingly refine the fit by repeatedly lowering one stone onto another, using a mixture of sand and water to abrade the high points until the two surfaces matched perfectly. This trial and error method, while logical, seems almost too slow and imprecise to account for the micrometer-level accuracy seen in the best joints. The fit is so perfect that it has withstood centuries of earthquakes that have toppled Spanish colonial buildings erected on top of the Inca foundations. The interlocking, three-dimensional puzzle of the walls acts as a dynamic structure that dissipates seismic energy, swaying with the earth rather than cracking apart, an ingenious feature that was almost certainly intentional. This gap between the proposed methods and the astonishing final product has, understandably, given rise to more speculative theories. Some suggest the Inca might have discovered a plant-based chemical agent that could temporarily soften the granite, allowing them to mold the stone like clay. While certain plants in the region do have acidic properties, there is no evidence they can affect hard granite on such a scale. More esoteric ideas propose the use of acoustic levitation or sonic technology, that the Inca possessed knowledge of specific sound frequencies that could negate gravity, making the stones weightless and easy to position. These theories, while captivating, remain firmly in the realm of speculation without any archaeological or historical evidence to support them. Perhaps the most compelling answer lies not in a single lost technology, but in a lost culture of knowledge. The construction of Sacsayhuamán was not a mechanical process but a deeply skilled craft, passed down through generations of master masons. Their understanding of stone, its grain, and its properties was likely so profound that it became an intuitive art. What appears to us as an impossible mystery may have been, for them, the culmination of centuries of accumulated empirical wisdom, a tradition of stonemasonry where the feel of the rock and the sound of the tap were as important as any blueprint. The true secret of Sacsayhuamán may not have been a magical tool, but an irreplaceable human expertise that vanished with the collapse of the Inca Empire, leaving behind these silent, monumental walls as a permanent challenge to our modern assumptions about the capabilities of the ancient world. From the monumental stone puzzles of the Andes, we travel to the Mediterranean island of Crete, where a far smaller but equally perplexing artifact was unearthed. In 1908, archaeologists excavating the Minoan palace of Phaistos discovered a fired clay disc about 6 inches in diameter that would become one of the most enduring enigmas in all of archaeology. Unlike the grand walls of Sacsayhuamán, the Phaistos Disc is a handheld object, but it carries a mystery of comparable weight. Its entire surface, front and back, is covered with a spiral of beautifully stamped symbols, a sequence of 45 distinct signs that include human figures, animals, plants, tools, and geometric shapes. From the moment it was found, this object presented a riddle with 3 layers. What does it say, what was it for, and why does it stand alone? The most immediate and frustrating challenge is the script itself. The symbols are not hand-drawn or carved. They were impressed into the soft clay with individual seals, making the Phaistos Disc one of the earliest known examples of movable type printing in the world, a technology that wouldn't reappear for another 3,000 years. Yet, this revolutionary method seems to have been a dead end. Not a single other example of these specific stamped symbols has ever been found anywhere on Crete or in the wider world. This absolute isolation is what makes decipherment virtually impossible. Normally, linguists crack ancient codes like the Egyptian Rosetta Stone by comparing the unknown script to a known language. With the Phaistos Disc, there is no parallel text, no bilingual inscription, no Rosetta Stone to provide a key. It is a message without a context, a language without a dictionary. This hasn't stopped countless attempts at translation, each one more speculative than the last. Some theorists propose it is a religious text, perhaps a hymn to a goddess, given the Minoans' well-documented spiritual practices. Others argue it is a legal document, a record of a treaty or a list of taxable goods. More imaginative interpretations suggest it could be a narrative, a story of a hero's journey, or even a board game with its rules inscribed around the spiral path. The direction of reading is itself a subject of debate. Does the spiral wind inward from the rim or outward from the center? Each proposed translation is built on a foundation of assumptions about Minoan society that cannot be proven, and as a result, none have gained widespread acceptance within the academic community. The disc remains stubbornly silent. The profound mystery of the Phaistos Disc leads to a much larger and more haunting possibility. What if this object is not just a unique oddity, but the sole surviving relic of an entire written language that flourished and then vanished without a trace? The Minoan civilization is known to have used other scripts like Linear A, which also remains largely undeciphered. but the symbols on the Phaistos disc are completely different, suggesting it may represent a separate, highly specialized form of communication. Perhaps it was used by a specific guild for a singular purpose known only to a select few. When the Palace of Phaistos was destroyed around 1400 years before the Common Era, that small group of literate individuals may have perished with it, taking the knowledge of how to read and write this script with them forever. This idea transforms the disc from a simple puzzle into a profound symbol of loss. It is a physical reminder of how fragile knowledge can be. An entire system of thought, a way of recording information, can be extinguished by a single volcanic eruption, an invasion, or the simple passage of time. The Phaistos disc is therefore more than an archaeological artifact. It is a message from the past about the transience of human achievement. It sits in its museum case not as an answer, but as a permanent question, challenging us to acknowledge the vast, silent gaps in our history and to wonder what other voices from the ancient world have been lost, leaving behind only a spiral of beautiful, unreadable signs. As we move from the silent enigma of the Phaistos disc, we encounter a lost technology that served a brilliantly practical purpose, one that enabled some of history's most daring explorers to conquer the treacherous North Atlantic. The Viking sagas speak of a mysterious tool called the solarstein, or sunstone, a crystal that allowed navigators to locate the sun's position even when it was completely hidden by cloud cover, fog, or the perpetual twilight of the polar summer. For a culture that ventured as far west as North America centuries before Columbus, relying on a sun that could vanish for days at a time, such a device would have been nothing short of magical. For centuries, this sunstone was dismissed as a mere legend, a poetic metaphor, but modern science and a handful of archaeological finds have revealed it was very likely a real, sophisticated navigational instrument based on the principles of light polarization. The scientific principle behind the sunstone is both elegant and ingenious. It hinges on a property of light that our eyes cannot normally detect. Sunlight traveling through the atmosphere becomes polarized, meaning its light waves vibrate in a specific direction relative to the sun's position. A crystal like Iceland spar, a transparent form of calcite found in Scandinavia, has a unique ability to split a beam of light into two separate rays. When you look through such a crystal and rotate it, the brightness of the image changes depending on its orientation to the hidden sun. By finding the orientation where the two beams of light emerging from the crystal are of equal intensity, a skilled user can pinpoint the exact direction of the sun, even if it is below the horizon. It's a natural GPS using the very fabric of the sky as its guide. The theory moved from plausible speculation toward probable fact with a key archaeological discovery. In the wreck of an English warship sunk in 1592, the Alderney shipwreck, archaeologists found a clear, rectangular piece of Iceland spar. While the ship was not Viking, its location and the nature of the artifact strongly suggested it was being used as a navigational aid, a practice that may have persisted from earlier Norse traditions. This tangible evidence provided a crucial link between the sagas and the physical world. Then, in 2013, a team of researchers put the theory to a rigorous test. They used a crystal of Iceland spar to navigate under overcast skies, demonstrating that the method could determine the sun's position with an accuracy of within a single degree, a level of precision more than sufficient for open ocean navigation. This technology would have given Viking navigators a monumental advantage. While other sailors were forced to hug the coastline or wait helplessly for the weather to clear, the Vikings could strike out across the open sea with confidence. A navigator would likely have carried a small, pocket-sized crystal, perhaps held up to the sky and rotated slowly while observing the changes in light intensity. This ability to see the invisible sun allowed them to maintain a steady course toward their destinations, whether it was the icy shores of Greenland, the wooded coasts of Newfoundland, or the trading posts of the British Isles. It was this edge, this mastery of the unseen, that underpinned the entire Viking age of exploration and settlement. The story of the Viking sunstone is a perfect example of how a lost technology can be rediscovered through the marriage of ancient texts and modern physics. It shows that the Vikings were not just fierce warriors, but also brilliant empirical scientists, keen observers of the natural world who understood how to harness its hidden properties. The solarstein was not a mythical talisman, but a functional, sophisticated tool born from a deep understanding of the environment. Its eventual fade from use was likely due to the adoption of the magnetic compass in Europe, a simpler, if less reliable tool that required less specialized knowledge. Yet for centuries, this piece of crystal represented the pinnacle of navigational science, a secret weapon that opened up a new world and then quietly vanished into the pages of legend, only to re-emerge as a testament to human ingenuity. Standing in the heart of Delhi, a testament to a forgotten metallurgical genius defies one of nature's most relentless forces, corrosion. This is the Iron Pillar of Delhi, a 23-foot-tall column of wrought iron that has endured for over 1,600 years, exposed to sun, rain, and monsoon humidity, yet it shows almost no signs of rust. In a world where steel bridges and cars require constant maintenance and protective coatings to fight a losing battle against oxidation, this ancient pillar's pristine condition is nothing short of miraculous. It wasn't created for a grand architectural purpose like supporting a temple roof. Inscriptions suggest it was originally erected as a standard to honor a Gupta dynasty king, perhaps Chandragupta II. But its true legacy is not the message carved into its surface, but the silent, enduring secret of its metal, a secret that modern industry inadvertently abandoned. The pillar's resistance isn't a matter of luck or a unique dry climate. It's a masterpiece of chemical engineering. The key lies in its unique composition, which was radically different from the formulas used in modern steel production. Analysis has revealed that the iron has an unusually high phosphorus content, around 0.25%, a level that would be considered an impurity in today's blast furnaces. Modern steelmaking is obsessed with removing phosphorus and sulfur to prevent brittleness, but the ancient Indian smiths used a direct reduction method, smelting iron ore with charcoal in a small furnace. This process didn't reach temperatures high enough to remove the phosphorus, so the element remained in the final metal. This impurity, it turns out, was the pillar's greatest strength. Here's how this ancient recipe works its magic. Over time, the high phosphorus content in the iron reacts with the oxygen and moisture in the air. But instead of forming the loose, flaky red oxide we know as rust, which continually exposes fresh metal to corrosion, it facilitates the creation of an astonishingly thin and stable protective layer. This layer, only a few hundred microns thick, is a compound called mesawite, a form of iron oxyhydroxide. Think of it as an invisible, self-healing shield. The phosphorus aids in the formation of this passive film by acting as a catalyst, ensuring it bonds tightly to the underlying metal. This film is so effective that it prevents further oxygen and moisture from penetrating to the iron below, effectively putting a halt to the corrosion process. It's a perfect, natural protective coating that grew stronger with age. The creation of this shield was a happy accident of the ancient forging technique, but its preservation was a matter of brilliant craftsmanship. The pillar itself is a single, massive piece of hand-forged iron, weighing over 6 tons. The smiths who made it would have hammer welded dozens of smaller iron pieces together at a white-hot heat, a process that naturally helped to distribute the phosphorus evenly throughout the metal. This meticulous forging eliminated slag inclusions and other weaknesses that could have served as starting points for corrosion. The smooth, polished surface of the pillar also plays a crucial role. A rough surface would trap moisture and compromise the protective film. Every aspect of its manufacture, from the chemical composition to the physical finish, contributed to its legendary durability. This achievement stands in stark contrast to our modern approach. Our industrial processes create iron and steel that is purer in a chemical sense, but far more vulnerable to the elements without constant human intervention. We spend billions on paints, galvanization, and sacrificial anodes to protect our structures, while a 16-century-old pillar relies on its own inherent chemistry. The tragedy is that the knowledge behind this was not so much lost as deliberately discarded. As the Industrial Revolution prioritized mass production and standardized formulas, the unique properties of high-phosphorus iron were forgotten, seen as a defect rather than a feature. Today, materials scientists are studying the iron pillar with a sense of reverence and a very practical goal: to reverse engineer its passive layer for modern applications. The potential is enormous. Imagine steel reinforcements in concrete that don't rust and cause concrete cancer, leading to bridges and buildings with vastly longer lifespans. Consider pipelines or offshore structures that could withstand harsh environments with minimal maintenance, drastically reducing costs and environmental impact. The iron pillar is no longer just a curious relic. It is a living laboratory offering clues to a more sustainable way of building. It challenges our definition of progress, suggesting that sometimes the most advanced solution isn't a new invention, but the rediscovery of an ancient wisdom written in metal, standing silently in the Indian sun for centuries. Now, let us leave the enduring metal of Delhi and journey to the stark, arid plains of southern Peru, where an entirely different kind of ancient marvel stretches across the desert floor. Here, spread over nearly 250 square miles of the Nazca Desert, lies one of the world's most breathtaking and perplexing archaeological puzzles. These are the Nazca Lines, a vast collection of geoglyphs, giant designs etched into the earth by removing the dark, sun-baked surface stones to reveal the lighter-colored sand beneath. From the ground, they appear as little more than shallow grooves, but from the vantage point of a nearby hill or an aircraft, they transform into a breathtaking gallery of colossal scale. You see a hummingbird with a beak longer than a football field, a spider with perfectly articulated legs, a condor with wings outstretched, and a monkey with an elaborately curled tail. Alongside these intricate biomorphic figures are sweeping geometric shapes, miles-long straight lines that run arrows straight to the horizon, immense trapezoids, and complex spirals. The sheer audacity of these creations is staggering, posing a dual mystery that has captivated researchers for decades. How were they made with such precision by people who could never see the full picture, and more profoundly, why were they made at all? The immediate technological challenge is one of perspective and scale. The Nazca culture flourished between 200 years before the Common Era and 600 years after, possessing a technology that did not include flight. How then did they design and execute these massive figures, some over 900 feet long, with such clean lines and perfect proportions that they only become coherent from hundreds of feet in the air? The answer lies not in alien intervention or lost aerial technology, but in a brilliant application of simple, scalable surveying techniques. Archaeologists like Maria Reich, who dedicated her life to studying the lines, proposed a method that is elegant in its simplicity. Small-scale models of the designs were likely first created on a more manageable surface. To scale these models up, teams of workers could have used a series of stakes and ropes. A central axis line would be established, and key points from the small model would be translated to the desert floor using a unit of measurement, perhaps based on human stride length. By stretching cords between these stakes, they could create straight lines and smooth curves on a monumental scale. The real genius of this method, however, was in quality control. How did they ensure the lines remained straight and the proportions accurate over such vast distances? The solution was likely a form of triangulation using natural landmarks on the distant horizon. By sighting along a series of intermediary stakes, crews could maintain a straight line with remarkable accuracy. For the complex curves of the animal figures, they may have used a technique where a cord was fixed to a central point and then swept in an arc, much like a giant compass. The desert environment itself was a crucial collaborator in this endeavor. The stable, windless climate and the unique combination of a dark, rocky surface layer over a light subsoil created a near-permanent canvas. Once the dark stones were removed, the contrast was sharp and enduring, a testament chosen specifically for its longevity. This was not a haphazard effort. It was a coordinated, sophisticated project requiring advanced planning, a clear chain of command, and a deep understanding of geometry. This leads us to the more profound and still unresolved question: what was the ultimate purpose of this immense undertaking? The effort involved was enormous, suggesting a motivation of critical importance to the Nazca people. One of the most compelling theories connects the lines to the most precious resource in the desert: water. The Nazca region is one of the driest places on Earth, and survival depended on managing underground aquifers and anticipating seasonal water sources. Some researchers have noted that many of the long, straight lines and trapezoids point directly toward sources of water in the distant foothills, perhaps marking ceremonial pathways for processions to pray for life-giving rain. The animal figures themselves might have been spiritual symbols, each representing a deity or a clan totem associated with water and fertility. The spider, for instance, was a symbol of rain in many Andean cultures, while the hummingbird was connected to the vital pollination that followed the rainy season. Another school of thought proposes an astronomical function, suggesting the lines formed a giant celestial calendar. Certain lines may have been aligned with the rising and setting points of the sun, moon, and significant stars during solstices and equinoxes, helping to mark the passage of the seasons for agricultural and ritual purposes. Yet others see a more communal and ritualistic purpose. The wide, trapezoid-shaped clearings could have served as ceremonial plazas where communities gathered for festivals, with the lines acting as sacred pathways for ritual walks. From the air, these pathways might have been intended not for human eyes, but for the gods themselves, a message inscribed on the earth to be seen from the heavens. The figures could have been offerings meant to be viewed by celestial deities in exchange for their blessings. The true purpose was likely a complex fusion of all these elements: astronomical, hydrological, and religious. The lines were not a single project with a single goal, but a cultural landscape developed over centuries, with different glyphs serving different functions for different generations. The mystery endures because the Nazca culture left no written records, and their worldviews vanished with them. The Nazca Lines stand as a monumental achievement of pre-Columbian engineering, a testament to human ingenuity in harmonizing art, science, and spirituality. They remind us that a technology need not involve gears or metals to be sophisticated. Sometimes the most advanced technology is the ability to organize human labor and vision on a grand scale, transforming an entire landscape into a message whose full meaning we are still striving to hear. Our journey now takes a fascinating turn in time, from the sprawling desert canvases of the ancients to the intimate workshops of Renaissance Italy, where a different kind of magic was being forged, not for the gods but for the human ear. In the small town of Cremona during the late 17th and early 18th centuries, a master luthier named Antonio Stradivari produced a series of violins that have become the holy grail of the music world. To this day, these instruments, known simply as Strads, are revered for a sound quality described as unparalleled. A rich, complex, and powerfully resonant tone that seems to carry a human-like voice within it. The perplexing fact is that despite over 3 centuries of technological advancement and scientific analysis, no modern violin maker has been able to fully replicate the acoustic perfection of a Stradivarius. The secret of their sound is a lost technology locked away in wood and varnish, a mystery that sits at the crossroads of art, science, and a unique moment in history. The quest to unravel this mystery begins with the very foundation of the instrument, the wood itself. Stradivari used spruce for the top plate and maple for the back, sides, and neck, woods commonly used by luthiers then and now. The difference, many experts believe, may lie in the specific climatic conditions of the time. The period from around 1645 to 1715 coincided with a climatic anomaly known as the Maunder Minimum, a time of unusually low solar activity that brought about a mini ice age in Europe. The long, cold winters and cool summers produced trees that grew very slowly, resulting in wood of an exceptionally tight, uniform grain. This dense, regular structure is thought to have created a wood that is both incredibly strong and remarkably lightweight, allowing it to vibrate with a purity and richness that faster-grown modern timber cannot match. Some researchers have even analyzed the wood's chemical composition, suggesting that the long floating of the logs down rivers to Cremona may have led to mineral deposits from the water impregnating the wood, further altering its acoustic properties. Yet, the wood is only part of the equation. Perhaps the most romanticized element of the Stradivarius secret is the varnish. The finish on these instruments is not merely a protective coating. It is a masterpiece in its own right, with a legendary recipe that Stradivari carried to his grave. For generations, the prevailing theory was that this varnish contained mystical ingredients, everything from crushed insect wings and gemstone powders to secret resins gathered from forgotten monasteries. Modern chemical analysis has demystified this somewhat, revealing a multi-layer finish. The base layer appears to be a simple sealant, likely a gum or protein-based size, intended to prevent the upper layers from soaking too deeply into the wood and dampening its vibration. The top coats are a complex mixture of oil, resin, and pigments. The real genius may not be in a single magical ingredient, but in the precise application and balance of these layers, creating a varnish that is flexible enough to move with the wood yet hard enough to protect it, contributing to the sound rather than stifling it. Beyond the materials, we must consider the irreplaceable element of the craftsman's hand. Antonio Stradivari was not just a carpenter, he was an acoustic architect who refined the designs of his predecessors over a long career spanning 7 decades. His precise arching, the subtle, carved curvature of the instrument's top and back plates, and the exact thicknessing of the wood at every point are believed to be critical. Using advanced imaging like CT scanning, researchers have mapped the density and thickness of Stradivarius violins in minute detail. They've found that the variations are not random. They follow a pattern of exquisite precision, thinner in some areas and thicker in others, creating a perfectly balanced resonant chamber. This was a knowledge gained not from computer models, but from a lifetime of tapping, shaving, and listening, an intuitive understanding of how to voice an instrument that was passed down through a guild system and died with the last of the great Cremonese masters. The final and most controversial theory introduces a form of accidental biotechnology. Some scientists have proposed that the wood was treated with fungicides or preservatives commonly used by timber merchants of the era, such as alum, borax, or various salts of copper and chromium. The purpose was likely to prevent worm and fungal damage, but a side effect may have been to partially break down the wood's hemicellulose and lignin, the complex polymers that give wood its structure. This chemical pretreatment could have effectively aged the wood artificially, reducing its density and altering its vibrational characteristics in a way that simply cannot be replicated by natural aging today. It's a compelling idea that the unparalleled sound of a Stradivarius might be, in part, the result of a practical solution to a mundane problem, a happy accident of preservation chemistry that gifted the wood with its unique sonic signature. In the end, the secret of the Stradivarius is likely not a single factor, but a perfect and unrepeatable storm. It was the convergence of unique climatic conditions providing perfect raw materials, a guild-based system fostering unparalleled skill, a mysterious varnish formula, and perhaps even a dose of chemical serendipity. Modern luthiers can create instruments that are technically perfect, and in blind tests, many skilled musicians sometimes prefer new violins for their power and consistency. Yet the Strads retain an almost mystical reputation for a depth and complexity of tone, a soulfulness that continues to elude precise definition and replication. They stand as a powerful reminder that the highest forms of technology are not always about machinery and gears, but can be embedded in the relationship between a master's hands, a specific natural environment, and a block of wood, creating an artistic legacy that resonates as powerfully today as it did 300 years ago. We now turn from instruments of exquisite sound to a creation of legendary sight, a wonder so magnificent that its very reality has been called into question. Among the 7 wonders of the ancient world, the Hanging Gardens of Babylon stand apart as the most elusive. While the Great Pyramid of Giza defiantly pierces the sky and the ruins of the Temple of Artemis hint at past glory, no physical trace of the gardens has ever been conclusively found in Babylon. Our knowledge of them comes not from spades and trowels, but from the pens of later Greek and Roman historians like Strabo and Diodorus Siculus, who described a breathtaking artificial mountain of terraced gardens, irrigated to create a lush green oasis in the heart of the Mesopotamian desert. This reliance on second-hand accounts, written centuries after the gardens were said to have been built by King Nebuchadnezzar II for his homesick Median wife, has led many scholars to wonder if they were ever more than a traveler's tall tale, a poetic ideal of royal power and love. Yet, the sheer audacity of the concept presents an irresistible engineering puzzle. Imagine the challenge, constructing a massive, multi-tiered structure, perhaps rising to a height of 75 feet or more, capable of supporting the immense weight of full-sized trees and deep soil, all in a hot, arid climate where water was a precious commodity. This was not a simple rooftop garden. The ancient descriptions suggest a vaulted substructure of stone arches and waterproof terraces, a building designed to bear a mountain. The primary engineering hurdle beyond the structural load was irrigation. How could enough water be lifted from the Euphrates River to the garden's highest levels against the relentless pull of gravity, and then distributed efficiently to prevent the roots from drying out in the blistering sun? This is where the concept of lost technology becomes so compelling. The proposed solutions point to a sophistication that seems to defy the era. Greek historians describe the use of screws to lift water, a technology later perfected by Archimedes but which may have had earlier antecedents in the East. An Archimedes screw, a large spiral housed within a cylinder when turned by human labor, could have been used in a cascading series to lift water from one terrace to the next. Another plausible method involves a complex chain pump system. This would consist of a continuous loop of buckets attached to a chain, powered by a large treadmill worked by laborers. The buckets would dip into a reservoir at the base, be carried upward through a concealed vertical shaft, and tip their contents into a channel at the top terrace, from which the water would flow downward through the garden via a network of canals and drains. Such a system would have required precise gearwork and a deep understanding of hydraulic principles. The mystery deepens with a theory that has gained significant traction in recent years, that the classical writers got the location wrong. Dr. Stephanie Daly of the University of Oxford has proposed a radical reassignment, arguing that the gardens were not in Babylon at all, but hundreds of miles to the north in the Assyrian capital of Nineveh. Her evidence is compelling, drawing on revised translations of cuneiform texts that describe a massive aqueduct system built by the Assyrian king Sennacherib around 700 years before the Common Era. This system, an incredible feat of engineering in its own right, used water screws to bring water from the mountains to his royal gardens, which he described in terms that eerily echo the later Greek accounts of Babylon. An ancient stone relief from Sennacherib's palace even appears to show a lush, terraced garden gracing a complex aqueduct. If Daly is correct, the mystery of the Hanging Gardens transforms. It is no longer a question of whether such a wonder could be built, but a case of mistaken identity across centuries. The technology did exist, but it was Assyrian, not Babylonian. The advanced irrigation and architectural techniques were real, yet they became attributed to the more famous city of Babylon in the stories passed down through generations. This possibility makes the loss of the knowledge even more poignant. With the destruction of the Assyrian Empire, the detailed understanding of how to build and maintain such a colossal hydraulic garden may have faded, leaving only fragmented descriptions that later cultures could scarcely believe were real. Whether in Babylon or Nineveh, the Hanging Gardens represent the pinnacle of ancient landscape engineering, a testament to humanity's desire to reshape nature itself, a lost marvel whose true story may still be waiting to be unearthed. While the Hanging Gardens tease us with their absence, our next treasure is a breathtaking object you can actually see for yourself, glowing under a museum spotlight as a testament to an almost supernatural ancient craft. In the British Museum sits a small, ornate Roman cup from the 4th century, known as the Lycurgus cup. At first glance, it appears to be a beautiful but opaque jade green, depicting a scene from the myth of King Lycurgus entangled by vines. But when a light is placed inside the cup, something miraculous happens. The green vanishes and the entire vessel glows with a stunning, translucent ruby red. This is not a trick of the light. It is a precise and deliberate technological marvel, a feat of nanoscale engineering that was not understood or replicated for over 1600 years. The secret behind this magical color change lies not in dyes or pigments, but in the very structure of the glass itself. Unbeknownst to the Roman artisans who created it, they had become masters of nanotechnology. The glass was infused with a meticulously measured mixture of gold and silver dust, ground so incredibly fine that the particles were smaller than a wavelength of light. We now call these particles nanoparticles. In each cubic millimeter of the cup's glass, there are millions of these minuscule metal fragments. Their size is the key to the entire phenomenon. When light hits the cup from the front, in what is called reflected light, these tiny silver particles scatter the light in a way that makes the glass appear green. But when light shines through the cup from behind in transmitted light, the gold nanoparticles dominate, absorbing the blue and green wavelengths of light and allowing the red wavelengths to pass through, creating the brilliant ruby glow. The craftsman had achieved a perfect balance of metal and glass to create this dichroic effect, a property we now see in modern technologies like transition lenses and stealth aircraft coatings. The manufacturing process they used to achieve this is as mysterious as the effect itself. Without electron microscopes or precision scales, how did they mix the metals into the glass with such exact proportions? The leading theory points to a method known as colloidal gold. The artisans likely created a suspension of gold and silver particles in a liquid medium, perhaps using a specific acid or even urine, which contains urea, to prevent the particles from clumping together as the glass was melted. This colloidal mixture would then be added to the molten glass batch. The real genius was in the heating and cooling cycle. The glass had to be annealed or cooled at a very specific and controlled rate. If cooled too quickly, the nanoparticles would not form properly, too slowly, and they would clump together, destroying the delicate color-changing property. This required an empirical, hands-on knowledge of materials that was passed down through generations of glassmakers, a feel for the process that was more art than science. The creation of the Lycurgus cup represents the pinnacle of a specific Roman glassmaking technique known as cage cup or diatratum work. This involved carving a thick blank of glass to create a delicate, lace-like outer network that stands away from the inner vessel, a process of incredible risk and skill that often resulted in breakage. To combine this supreme sculptural challenge with the unknowing mastery of nanoparticle chemistry is an achievement that borders on the unbelievable. It suggests the existence of specialized workshops where artisans pushed the boundaries of their materials to create luxury items for a wealthy elite. Objects that were as much demonstrations of philosophical and technical prowess as they were drinking vessels. And then, this knowledge simply vanished. With the decline and fragmentation of the Roman Empire, the complex supply chains, the specialized workshops, and the oral traditions of these master glassmakers were lost. The secret of dichroic glass disappeared from history until the 19th century, when glassmakers like Louis Comfort Tiffany began experimenting with metallic oxides to create iridescent effects. And it wasn't fully understood until the 20th century with the advent of electron microscopy. The Lycurgus cup thus stands as a singular relic of a forgotten technological path. It is a tangible piece of evidence that ancient craftsmen were not just skilled artisans but intuitive materials scientists, manipulating matter at a scale invisible to the human eye to create a wonder that would not be comprehended again until the modern era. From the delicate nano-alchemy of the Lycurgus cup, we now travel to the windswept hilltops of Scotland, where a far more rugged and puzzling mystery is baked into the very stones of ancient fortresses. Scattered across the British Isles and parts of Europe are the remains of Iron Age hill forts, but some of these structures hold a secret that has baffled archaeologists for centuries. Their massive stone ramparts built from countless granite boulders are not merely stacked. In many sections, they have been fused together into a solid, glassy slag. This is the enigmatic phenomenon of vitrified forts, where stone walls have been subjected to such incredible heat that they have literally melted and then resolidified, turning into a crude, dark glass. The scale is immense. Entire sections of walls, sometimes meters thick, have been transformed. The question that has haunted researchers since the 18th century is a simple one. Who or what could generate the temperatures necessary to melt solid rock? And more importantly, why would anyone do this on purpose? The most immediate challenge is the sheer physics involved. Granite, the primary stone used in these structures, does not melt like ice. It requires sustained temperatures of well over 1,000 degrees Celsius, and in some cases up to 1,200 degrees to even begin to liquefy. This is the temperature of a modern industrial furnace or a volcanic eruption. Achieving this with the technology of the Iron Age, which was limited to wood fires and perhaps some charcoal, seems almost impossible outdoors and on such a monumental scale. The heat required would be immense and, crucially, evenly distributed enough to fuse the entire core of a wall rather than just scorching its surface. This core mystery has given rise to several competing theories, each with its own compelling evidence and significant drawbacks. The leading conventional explanation is that the vitrification was a deliberate act of defensive architecture. Proponents of this theory suggest that ancient builders constructed wooden cribbing, essentially huge, box-like frameworks within the stone walls. These boxes would have been filled with a specific type of rock rich in silica, perhaps mixed with combustible materials like timber and brushwood. The entire structure would then be set ablaze in a controlled manner. The burning wood would provide the initial heat, and the silica-rich rocks would act as a flux, lowering the melting point of the surrounding granite. As the inferno raged, the stones would begin to melt and flow together, and when the fire died down, the result would be a solid, monolithic wall far stronger and more resistant to battering rams and erosion than a simple dry stone stack. This fused rampart would be incredibly difficult to breach, creating a formidable defensive barrier. However, this controlled burning theory faces some serious logistical hurdles. Modern experiments to recreate this process have largely failed. While small-scale tests can produce localized vitrification, no one has managed to sustain the heat for long enough or distribute it evenly enough to fuse a wall section even a fraction of the size of those found at sites like Tap O' Noth in Scotland or Peyron in France. The amount of timber required would have been staggering, denuding entire landscapes for a single fortification. Furthermore, the process would be incredibly dangerous and difficult to control. A fire of that magnitude could easily rage out of control, threatening the very people building the fort. If it was a deliberate construction technique, it was one of extreme risk for a reward that remains debatable. This has led to a second, more dramatic theory, that the vitrification was not intentional construction, but the result of catastrophic destruction. Perhaps these forts were not melted to be strengthened, but were burned down by a vengeful enemy in a conflagration of such intensity that the very stones ran like wax. The Iron Age was a violent time, and the complete annihilation of an enemy's stronghold would have been a powerful statement. A massive siege fire, perhaps fueled by accelerants like animal fat or oil, could have created the necessary inferno. This would explain the sometimes uneven and chaotic nature of the vitrification, as an attacking force would not have been concerned with creating a neat, solid wall. The vitrification would then be a permanent scar, a testament to a devastating defeat burned into the landscape. Yet, even the destruction theory struggles with the physics of the heat required. This has opened the door to more speculative and controversial explanations. Some researchers point to the possibility of a massive natural plasma event, such as a lightning strike of unprecedented power or a near miss from a cosmic object like a meteor or comet. A plasma arc can generate temperatures far exceeding those of any ordinary fire, capable of almost instantaneously fusing stone. There are even fringe theories that propose these forts are evidence of some form of lost ancient energy weapon, a technology capable of projecting intense heat onto enemy fortifications. While these ideas capture the imagination, they remain firmly in the realm of speculation, lacking any corroborating evidence from the archaeological record or historical accounts. The true answer may be a combination of factors unique to each site. Perhaps some forts were deliberately vitrified using a technique we have yet to rediscover, one that required a specific geological knowledge of local rocks. Others may have been accidentally fused during a particularly destructive sacking. What remains undeniable is the physical evidence itself. To stand at a site like the Tap o' North and run your hand over the grotesque, bubbled surface of a wall that flowed like liquid 3,000 years ago is an eerie experience. It confronts us with the limits of our understanding of the past. The vitrified forts are a stark reminder that the ancient world still holds secrets that defy our conventional explanations, presenting us with a landscape permanently altered by forces we can measure, but whose origin we cannot yet fully name. Just as the Romans were mastering glass and the Celts were building their fiery forts on the other side of the world, a Han Dynasty inventor was grappling with one of nature's most unpredictable and devastating forces, the earthquake. In the year 132, the brilliant polymath Zhang Heng presented the court of Emperor Shun with a device so far ahead of its time that it would not be equaled for over 1,500 years. This was the world's first seismoscope, an instrument capable of detecting earthquakes from hundreds of miles away. Imagine a large, ornate bronze urn, beautifully decorated and encircled by 8 dragon heads, each one gazing out in a cardinal or intercardinal direction. In each dragon's mouth rested a perfectly balanced bronze ball. Below each dragon, with mouths agape, sat 8 corresponding bronze toads. The elegance of the design belied its profound purpose. When the earth trembled somewhere in the vast Han Empire, this silent sentinel would come to life, not with a rumble, but with a single, resonant clang, as one dragon would release its ball directly into the waiting mouth of the toad below, announcing both the occurrence and the direction of the distant quake. The historical records, particularly from the Book of the Later Han, tell a story that seems to border on magic. On one occasion, a dragon facing west dropped its ball, yet no one in the capital city of Loyang had felt even the slightest tremor. Skeptics dismissed the device as a failure, but several days later, a messenger arrived from a commandery located hundreds of miles to the west, reporting a major earthquake that had struck at the exact moment the dragon had spoken. It was this event that reportedly convinced the court of the machine's astounding accuracy, transforming it from a curious artifact into a vital tool of imperial administration. In an empire as vast as the Han, where timely information was crucial for dispatching aid and maintaining control, this early warning system was a technological marvel. It provided the court with a critical head start, allowing them to learn of a disaster in a distant province days before a messenger could possibly arrive on horseback. The true and enduring mystery of Zhang Heng's seismoscope lies not in its reported success, but in its lost internal mechanism. The ancient texts describe what it did, but they guard the secret of how it worked. The device was lost to history, likely destroyed in the turmoil that followed the Han dynasty's collapse, and with it, the precise engineering knowledge vanished. For centuries, it was little more than a legend. Modern scientists and historians have been left to reverse engineer its function based solely on the brief descriptions, leading to a fascinating and ongoing debate. The most widely accepted theory proposes that a cleverly weighted pendulum was suspended in the center of the vessel. When seismic waves, the primary waves that travel fastest from an epicenter, arrived, they would set the pendulum swinging. The pendulum would then strike a lever or a mechanism connected to one of the 8 dragon heads, tripping a latch and releasing the ball from the dragon facing the direction of the quake. This explanation is elegant and mechanically plausible, aligning with basic principles of physics. However, other theories push the ingenuity even further. Some researchers suggest the mechanism might have been more sophisticated, perhaps involving an inverted pendulum that was naturally unstable and would fall in the direction of the initial shockwave. Another compelling idea involves the use of an inertia-based system, where a mass suspended in a liquid would remain relatively stationary while the vessel moved around it, triggering the release. The challenge with all these models is replicating the described sensitivity with the materials and precision available in the 2nd century. How could a device distinguish the subtle, directional push of a distant earthquake's primary wave from the general shaking that would follow? This level of discrimination suggests a mechanical refinement that seems almost miraculous for its time. Creating functional replicas has been a project of passion for many. In 2005, a team of scientists and archaeologists in China constructed a working model based on the pendulum theory, and it successfully detected simulated earthquakes from various directions. Yet, even the creators admit their design is speculative. It works, but is it the way Zhang Heng's original worked? We may never know for certain. The loss of this technology is particularly poignant because it represents a path not taken. While Europe would not develop a similar instrument until the 18th century, Zhang Heng had created a functional earthquake detector that integrated sophisticated mechanics, metallurgy, and a profound understanding of geophysical phenomena. It stands as a solitary peak of genius, a reminder that the history of science is not a smooth, continuous line, but a landscape dotted with forgotten summits whose secrets are waiting to be rediscovered. Our exploration of ancient ingenuity now takes us to a scene of legendary defense, where one of history's greatest minds is said to have turned the sun itself into a weapon. During the siege of Syracuse in the Second Punic War, around 214 years before the Common Era, the Roman fleet led by the general Marcus Claudius Marcellus faced an unexpected and terrifying adversary, the 74-year-old inventor Archimedes. Historical accounts, written centuries later by authors like Lucian and Anthemius, describe a device so audacious it seems pulled from myth. As the Roman galleys approached the city walls, Archimedes allegedly deployed an array of highly polished bronze shields or mirrors. These were not for deflecting arrows, but for concentrating the intense Mediterranean sunlight into a single, searing point of heat on the wooden hulls of the ships, setting them ablaze from a distance. The story paints a picture of the ultimate triumph of intellect over brute force, a brilliant scientist harnessing a fundamental force of nature to protect his home. The central question, of course, is whether such a weapon was physically possible or merely a powerful allegory for Archimedes' genius. The principle behind it, known as the burning mirror, is sound science. We use the same concept of focusing light with lenses or reflective surfaces every day, from starting a fire with a magnifying glass to the vast arrays of mirrors in modern solar power plants that generate immense heat. The challenge for Archimedes would not have been the theory, but the practical execution on a scale sufficient to threaten a warship. A single, small mirror would be useless. The concept requires a large, coordinated array of mirrors, all focusing their reflected beams onto a small, moving target hundreds of feet away, all while under the stress of a naval assault. The precision needed to maintain that focus on a ship rocking on the waves would have been immense. This very question has captivated scientists and engineers for centuries, leading to a series of fascinating modern experiments with decidedly mixed results. In 1973, the Greek scientist Ioannis Sakas conducted a famous test. Using 70 polished copper mirrors, similar to those available in Archimedes' time, he trained them on a plywood mock-up of a Roman ship anchored about 160 feet away. According to his report, the wood smoldered and then caught fire within seconds. This experiment seemed to validate the legend. However, subsequent attempts have been far less conclusive. A team from the Massachusetts Institute of Technology tried to replicate the feat in 2005 for the television show Mythbusters. They used 500 mirrors held by students aiming at a stationary wooden boat. While they could scorch the wood and even create some flame with the target standing perfectly still, they found it nearly impossible to sustain the intense heat needed for a sustained fire, especially on a moving vessel. The Mythbusters team ultimately labeled the myth busted, arguing that the conditions required were too perfect and the strategy too unwieldy for the chaos of battle. The debate, therefore, hinges on the gap between theoretical possibility and practical battlefield application. Proponents of the weapon's feasibility argue that we must consider the context. Archimedes was a master of mechanics and optics, and the Romans themselves documented their terror of his other war machines, like massive claws that lifted ships from the water. It is not unreasonable to think he could have engineered a stable frame to hold and precisely adjust an array of mirrors operated by a trained crew. The target would also have been closer than in some modern tests, and the hulls of Roman ships were coated with flammable pitch, which could have ignited more easily than bare wood. A momentary ignition could have spread rapidly, creating the reported effect. Skeptics, however, point to the lack of contemporary evidence. The historian Polybius, who wrote the most detailed account of the siege only 70 years after the event, makes no mention of the death ray. He describes Archimedes' other fantastic engines in detail, but the burning mirror story only appears in texts written several hundred years later. This suggests it may be a later accretion, a legend that grew around the inventor's reputation to further amplify his mythic status. It is possible the story conflates the use of polished shields to dazzle and disorient Roman troops, a plausible tactic with the more dramatic idea of starting fires. Ultimately, whether the death ray was a tangible weapon or a symbolic tale may be less important than what it represents. It stands as a powerful symbol of lost inventive genius, a testament to the boundless creativity attributed to Archimedes. The very fact that the story has persisted for 2 millennia, sparking debate and scientific inquiry, speaks to its enduring power. It captures our imagination because it embodies the ideal of intellect overcoming overwhelming force, of a solitary thinker using his understanding of the universe to alter the course of history. The legend of the death ray ensures that Archimedes is remembered not just for his mathematical principles and mechanical screws, but as a figure whose brilliance was so profound that it blurred the line between science and myth, leaving behind a legacy that continues to inspire and challenge us to wonder what other secrets of the ancient world remain hidden in the shadows of history. While Archimedes was said to be harnessing sunlight, the Inca Empire was mastering a different kind of language, one written not with light or ink but with knots. We journey now to the Andes, where the most extensive and sophisticated information system in the pre-Columbian Americas flourished, only to be deliberately unraveled by conquest. This is the story of the quipu, an array of knotted cords that for centuries was dismissed by Western scholars as a primitive counting tool, little more than an abacus for tracking livestock or tribute. But emerging research is revealing a far more breathtaking possibility, that these intricate arrangements of strings were in fact a complex three-dimensional writing system, a lost language of knots that held the history, laws, and stories of a vast empire. At its most basic level, a quipu is a collection of cotton or camelid wool cords, often hanging from a primary horizontal strand. The genius of the system lies in its multi-layered coding. A quipu maker or quipukamayok could encode information through several variables simultaneously. The position of the cord, the type of knot, the number of knots, the spacing between them, and critically, the color of the string itself. For recording numerical data, the system was brilliantly efficient. They used a base 10 positional system, much like our own. A figure of 8 knot represented the number 1. A long knot with a specific number of turns could represent the numbers 2 through 9, and a granny knot signified a place value tens, hundreds, thousands. By reading the knots on a series of cords, a trained official could ascertain precise census data, agricultural yields, or military logistics with astonishing speed and accuracy. This administrative function alone made the quipu the central nervous system of the Inca Empire, enabling the coordination of millions of people across thousands of miles of rugged terrain. But what if the quipu could do so much more than just math? This is where the mystery deepens into a profound historical tragedy. Spanish chroniclers from the 16th century recorded that the Inca used quipus to record everything from historical narratives and poetry to laws and genealogies. One account describes how, after the Spanish conquest, a quipukamayok unfurled a complex quipu and recited from it the entire history of the Inca people, generation by generation. This suggests that the quipu was not merely a prompt for a memorized story, but the actual storage medium for the narrative itself. The key to unlocking this non-numerical dimension likely lies in the elements we understand the least: the colors of the cords, the direction of the spins in the ply, and the complex relationship between pendant cords and their subsidiaries. A red cord might signify a warrior, while a specific shade of yellow could represent corn, and their combination on a particular branch of the quipu might tell a story of a battle fought over a harvest. It was a semantic, symbolic language, a binary code written in fiber rather than silicon. The suppression of this technology was systematic and brutal. The Spanish conquistadors and priests, recognizing that the quipu was a source of indigenous authority and a repository of non-Christian history, declared them idolatrous objects. They launched a campaign to find and burn them, a cultural genocide of information that destroyed countless libraries of knotted knowledge. The quipukamayok's, the librarians and scribes of this system, were persecuted, and the knowledge of how to read the full complexity of the quipu was driven underground and then extinguished within a few generations. What survived were mostly quipus used for mundane accounting, which only reinforced the colonial view of them as simple tools. The richer narrative quipus, the ones that held the soul of the culture, were the primary target and were lost forever. Today, scholars like Harvard's Gary Urton are leading a monumental effort to decipher the quipu, treating it much like an undeciphered ancient script. They are using databases to catalog every known surviving quipu. Only about 600 remain, analyzing the patterns of knots, colors, and structures for a grammatical logic. The goal is to find a Rosetta Stone, a document that might pair a quipu with a clear Spanish or Quechua translation. Some hope rests on recently discovered colonial documents that suggest Spanish authorities sometimes accepted quippers as legal evidence in court cases and may have transcribed their content. Finding one of these paired transcripts could crack the code wide open. The quest is urgent as it represents a chance to hear the Inca speak in their own voice, not through the filter of their conquerors. The silent knots of the quipu are a haunting legacy, a stark reminder that a writing system can be lost not just to the ravages of time, but to the deliberate erasure of a culture's memory, leaving behind a tangled web of questions about an empire we have only just begun to understand. Deep within the rugged highlands of northeastern Laos lies a landscape that feels less like an archaeological site and more like a giant's abandoned workshop. Spread across dozens of sites on the Sacsayhuamán Plateau is the Plain of Jars, a vast collection of thousands of massive stone vessels, some standing taller than a person and weighing many tons. Carved from hard sandstone and granite, these monumental jars are scattered in clusters across the grassy plains, their origins stretching back over 2,000 years to the Iron Age. Their presence is both awe-inspiring and deeply mysterious, posing a dual puzzle that has challenged researchers for decades. What was the purpose of these colossal containers, and more pressingly, given the tools and terrain, how on earth were they ever made and moved? The most widely accepted theory, supported by archaeological evidence found inside and around the jars, points to a funerary function. Excavations have uncovered human remains, burial goods like beads and ceramics, and quartz stones that may have been used as grave markers. This suggests the jars served as either primary burial urns, holding the bodies of the deceased for a form of excarnation, where the elements would clean the bones, or as secondary repositories for skeletal remains after the flesh had decomposed. In this sense, the Plain of Jars can be seen as a vast, open-air cemetery, a sacred landscape where communities honored their dead with monuments of enduring stone. Local legends, however, tell a far more colorful story. They speak of a race of giants, the Kun Cheung, who inhabited the plateau and crafted the jars to brew immense quantities of rice wine to celebrate a great military victory. While this is a poetic explanation, the reality of their creation required a different kind of giant, the giant effort of human ingenuity. The technological enigma begins with the quarrying. The stone for the jars, primarily a hard sandstone and sometimes a more challenging granite, was not sourced from the plains where they sit. Geological analysis has traced the material to quarries located several miles away, often in nearby foothills. The first mystery is how ancient people without iron tools harder than the stone itself managed to carve these multi-ton blocks from the bedrock. The likely method involved a combination of fire and water. Workers may have built fires against the rock face to heat the stone, then rapidly cooled it by dousing it with water. This thermal shock would cause the rock to fracture along natural fault lines, creating large, manageable sections. Then, using stone hammers and possibly iron chisels, though evidence for ironworking in the region during that period is scarce, they would have painstakingly shaped the rough blocks into the familiar cylindrical form with an interior cavity. The precision of the carving, with its flared rims and smooth interiors, suggests a high degree of skill and specialized knowledge passed down through generations of stonemasons. But the quarrying is only half the battle. The truly staggering part of the process was transportation. How did these ancient people move jars weighing several tons each across miles of rugged, mountainous terrain without the wheel, without paved roads, and without the aid of draft animals like oxen or elephants? The logistics are mind-boggling. The most plausible theory involves an immense communal effort combining simple machines with raw human power. It is thought that the jars were likely moved in a partially finished state to reduce their weight. Teams of laborers would have used wooden rollers, levers, and ropes made from vines or hemp to inch the colossal stones forward. The path may have been prepared with log roads, and the most challenging slopes might have been negotiated using a system of ropes and pulleys or by dragging the jars up earthen ramps. This would have been a slow, dangerous, and extraordinarily labor-intensive process, speaking to the immense social organization and shared purpose of the culture that built them. Adding another layer of profound mystery is the simple fact that we do not know who this culture was. The jars predate any known civilization in the region, and no accompanying settlements of significant size have been discovered nearby. The creators left behind no written records, no carvings on the jars themselves to explain their mission. They are a people defined almost entirely by their funerary monuments. This absence makes the technological achievement all the more remarkable. It was accomplished by a society that has otherwise vanished from history. Compounding the mystery is the presence of stone discs often found nearby, which are sometimes marked with mysterious figurative carvings of humans and animals. These could be grave markers or ritual objects, but their meaning, like the jars themselves, remains just out of reach. The quest to understand the plane of jars continues, but it is a race against time and tragedy. The region was heavily bombed during the Vietnam War, and the landscape remains littered with unexploded ordnance, making large-scale archaeological excavation perilous. Efforts led by UNESCO, which has designated the site a World Heritage Danger List property, are slowly and carefully clearing areas for study. Each new excavation offers a potential clue, but the full story of the jar's creation may never be completely recovered. They stand as silent, stoic sentinels, a testament to a lost culture's mastery of their environment and their profound reverence for the dead. The Plain of Jars is not just a collection of ancient artifacts. It is a monumental landscape that challenges our perceptions of what ancient societies were capable of achieving. A haunting reminder that some of the greatest technological feats in human history were accomplished not with complex machinery, but with coordinated will, simple tools, and a knowledge of stone that has since been lost to the ages. Now we turn from the mysterious stone jars of Laos to a civilization that performed an equally astonishing miracle by making the desert itself bloom with life. When you picture the lost city of Petra, carved into the rose-red cliffs of southern Jordan, your mind likely conjures images of the magnificent treasury building, its intricate facade glowing in the sun. But the true wonder of Petra is not what you see carved into the rock, but what flowed through it. In one of the most arid regions on Earth, the Nabateans did not just build a city. They engineered an oasis, creating a water management system of such sophistication that it rivals and in some ways surpasses the more famous aqueducts of Rome. Their mastery over a scarce and often destructive resource allowed a metropolis of 30,000 people to thrive in the heart of the desert, a feat of engineering that vanished along with their kingdom. The foundation of this achievement was a profound understanding of the desert environment, particularly its most dangerous and unpredictable feature, the flash flood. The canyons or sick that lead into Petra are not gentle riverbeds but dry, sculpted chasms. For most of the year, they are silent and empty, but when the rare torrential rains fall on the surrounding plateau, these channels can transform in minutes into raging torrents of water, mud, and rock, capable of scouring the landscape clean. Instead of fighting this power, the Nabateans chose to harness it. Their entire water system was designed not just to collect water, but to tame the desert's fury, turning a destructive force into a life-saving resource. This began high in the hills with a network of diversion dams. These were not massive structures meant to create reservoirs, but cleverly placed barriers designed to intercept flash floods at their source. As water rushed downhill, these dams would capture the initial sediment-heavy surge, channeling the cleaner water that followed into a meticulously planned system. From these diversion points, the Nabateans carved channels along the canyon walls. Walking through the main Sikh today, you can still see the remains of these narrow, covered conduits, sometimes tunneling straight through the rock, sometimes running along a carefully constructed ledge. They slope at a near imperceptible gradient, a precise angle calculated to keep the water flowing at a steady, controlled pace all the way to the city center. Within the city itself, the system reached its peak of complexity, an extensive web of terracotta pipes, some small enough to serve individual homes, distributed water throughout Petra. These pipes were not simply laid in the ground, they were part of a pressurized system, a concept the Romans also used but which is astounding to find in a desert kingdom. This pressure allowed water to be directed uphill to reach cisterns and pools in the highest parts of the city, including the mountaintop altar known as Ad-Dair. The Nabateans lined their reservoirs and cisterns with a special waterproof plaster called hazar, a mixture of lime and crushed pottery that prevented precious water from seeping back into the thirsty ground. Every drop was measured, controlled, and conserved. The true genius of the Nabateans, however, lay in their grasp of geology. They understood that the very rock of Petra, its sandstone cliffs, was a natural water filter. They constructed their channels and cisterns to take advantage of the rock's porosity and natural fissures. In some areas, they carved deep, bell-shaped cisterns directly into the bedrock, which not only stored water but also minimized evaporation in the searing desert heat. Their entire approach was one of working with the landscape, using its natural properties to augment their own engineering, a sustainable model of urban planning that feels remarkably modern. When the Roman Empire absorbed the Nabatean kingdom in the 2nd century, they recognized the value of Petra's location but may have failed to fully grasp the subtleties of its water system. As trade routes shifted and a major earthquake in the 4th century damaged the infrastructure, the knowledge required to maintain this delicate balance began to fade. The system's decline was slow but inevitable. Channels silted up, cisterns cracked, and the delicate balance was lost. Eventually, the mastery of hydraulics that had sustained a desert capital was forgotten, and Petra was gradually abandoned to the sands, its water secrets buried along with its buildings. The city's fate is a powerful lesson in the fragility of technology. Even the most advanced systems require a living culture of knowledge to sustain them, and when that culture disappears, the desert inevitably reclaims its own. Moving from the hydraulic genius of Petra, we encounter a mind whose inventions seem to leap from the pages of science fiction into the workshops of ancient Alexandria. Heron, also known as Hero of Alexandria, was a 1st-century engineer and mathematician whose creations represent a breathtakingly different path that ancient technology could have taken. In his sprawling body of work, we find not just practical tools, but whimsical automata and engines that harnessed the fundamental forces of steam and wind. His most famous device, the Eolipile, stands as a haunting what-if in the history of technology. Often described as the world's first recorded steam engine, it was a simple but brilliant sphere mounted on a boiler. As the water boiled, steam was forced through 2 opposing nozzles, causing the sphere to spin rapidly on its axis. It was a clear, tangible demonstration of the principle of action and reaction, a working model of steam power that predated the Industrial Revolution by nearly 1700 years. Yet for Heron and his contemporaries, the Eolipile was not seen as a source of industrial power. It was categorized as a wonder, a philosophical toy, to demonstrate a scientific principle and to amaze audiences in temples or at royal courts. This perception is the core of the mystery surrounding Heron's work. He possessed the fundamental knowledge to spark a technological revolution, but the social and economic context was utterly absent. In an economy built on slave labor, there was no pressing need to develop labor-saving machinery. The idea of using the Eolipile to pump water or grind grain simply did not emerge as a practical application. It remained a fascinating curiosity, a seed of immense potential that fell on barren ground. its principles preserved in manuscripts but left undeveloped for centuries. This pattern of creating automata for wonder rather than work is perfectly illustrated by another of Heron's marvels, the wind-powered organ. This device was a masterpiece of integrated engineering, a true example of ancient automation. It began with a horizontal wind wheel similar to the sails of a windmill, placed outdoors to capture the breeze. As the wind turned the wheel, it connected through a series of gears and cranks to a simple piston pump. With each rotation, the pump would force air into a reservoir, building up pressure. This pressurized air was then channeled to the pipes of a water organ, creating a continuous, automated music machine that played solely from the power of the wind. Here was a machine that converted natural, renewable energy into a complex cultural output, music, without any human intervention once it was set in motion. The wind-powered organ was more than just a musical novelty. It was a sophisticated harnessing of natural power for a purely aesthetic purpose. It combined principles of pneumatics, mechanics, and musical theory into a single, self-operating system. Heron also described other automata in his writings, such as automatic temple doors that opened seemingly by divine will when a fire was lit on an altar, a trick accomplished by hidden pots of water heating air to displace weights, and coin-operated vending machines that dispensed holy water. These inventions reveal a society that valued cleverness, spectacle, and the demonstration of philosophical principles. They were created to inspire awe, to enhance religious ceremony, and to showcase the ingenuity of their creator. The fate of Heron's knowledge is a profound lesson in the nature of technological progress. His manuscripts, like the Pneumatica and Automata, were preserved by Arab scholars during the Middle Ages and later rediscovered in Renaissance Europe, where they influenced thinkers like Leonardo da Vinci. The designs were not lost, but their potential was dormant. The world had to wait for a society that viewed technology not as a source of wonder for the elite, but as a tool for universal economic and social transformation. The Industrial Revolution required not just the technical blueprint of a steam engine, but a culture of entrepreneurship, a need for mass production, and a mindset that saw machines as instruments of progress rather than as philosophical amusements. Heron of Alexandria possessed a spark of genius that was, in many ways, ahead of its time, leaving behind a legacy that challenges our linear view of history and reminds us that invention is only half the story. The other, more crucial half is the world's readiness to embrace it. Surviving examples of these plaques reveal a staggering command of texture and dimension. The artists could capture the intricate weave of a warrior's armor, the delicate patterns of a ceremonial robe, or the powerful musculature of a leopard with a realism that seems to breathe life into the metal. This was possible because the initial wax model was so malleable. An artisan could carve the finest lines, add thin layers for raised patterns, and sculpt forms with a freedom impossible to achieve by carving directly into stone or wood. Every scratch, every impression made in the soft wax would be perfectly preserved in the final bronze. The result was not merely a picture on a wall. It was a dense, textured narrative, a complex visual archive of the kingdom's court life, its military victories, and its spiritual beliefs, all rendered with a precision that rivals the finest European engravings of the same era. The true technological peak, however, was the mastery of the casting itself, a procedure fraught with risk. After the wax was melted out, the hollow clay mold was essentially a fragile, complex eggshell waiting to be filled with liquid metal heated to over 1000 degrees Celsius. A single flaw, an air bubble trapped in the mold, an impurity in the bronze alloy, or an uneven heating of the mold could cause a catastrophic failure, ruining weeks or months of painstaking work. The Edo metallurgists developed an ingenious solution to these challenges. They would often bury the hot mold in a pit of sand just before the pour. This served two critical purposes. It supported the mold from the outside, preventing it from cracking under the thermal shock and the weight of the metal, and it allowed the bronze to cool slowly and evenly, preventing bubbles and ensuring the metal flowed into every minute crevice of the design. This careful control over the entire thermal process speaks to a deep, empirical understanding of material science that was passed down through generations within specific guilds. This golden age of Benin artistry and technology came to a sudden and brutal end in 1897. In what became known as the British Punitive Expedition, a British military force attacked and captured the city of Benin, partly in retaliation for an earlier ambush. The subsequent looting was systematic and devastating. Thousands of bronze plaques, sculptures, and ivory carvings were seized as war booty, with many eventually sold to museums and private collections across Europe. This event was more than just a plundering of art. It was a calculated act of cultural destruction aimed at dismantling the power structure of the kingdom. The royal court, which had been the sole patron and preserver of this technological tradition, was exiled. The guilds of master casters were dispersed, and the transmission of knowledge from one generation to the next was violently severed. In an instant, a continuous lineage of technical excellence stretching back centuries was broken. For decades, it seemed the secrets of the Benin bronzes were lost forever, known only through the plundered objects now displayed as exotic curiosities in foreign institutions. The technique itself became a ghost, a memory of a past glory. Yet, in a remarkable story of cultural resilience, the art did not completely die. In the mid-20th century, a revival began, spearheaded by a few determined descendants of the original guilds who worked to piece the process back together. They studied the ancient bronzes with new eyes, reverse engineering the methods of their ancestors. Today, while the historical context can never be fully restored, the lost wax technique is once again practiced in Benin City, a testament to the enduring power of human creativity. The story of the Benin bronzes is therefore a dual narrative, one of an unparalleled technological achievement born from a unique culture, and another of a fragile knowledge that was nearly erased, reminding us that the greatest loss is often not the object itself, but the living, breathing wisdom required to create it. Standing in stark solitude against the vast expanse of the Pacific Ocean, the monumental stone heads of Easter Island or Rapa Nui are icons of mystery. But the true enigma lies not just in their brooding, stoic faces, but in the incredible journey they undertook. Scattered across the island are nearly 900 of these statues, known as moai, with the largest standing over 30 feet tall and weighing a staggering 82 tons. The quarry where they were born, the volcanic crater of Rono Roroku, is a breathtaking landscape of half-carved giants, a workshop frozen in time. Yet the ceremonial platforms, the ahu, where the moai were finally erected, are often miles away across rugged, rolling terrain. For centuries, this disconnect has fueled one of archaeology's most captivating puzzles. How did a society with no wheels, no draft animals, and no metal tools accomplish this Herculean feat of transportation? And why does their specific method remain a lost secret? One of the most persistent and visually striking theories, popularized for decades, suggested that the moai were literally walked to their destinations. This idea proposed that teams of rope pullers would rock the statue from side to side, inching it forward in a coordinated, upright shuffle. The image is undeniably compelling, a giant stone figure seeming to march across the landscape under human power. Proponents argued that the statue's distinctive design, with a heavy, bulbous base that leans forward, could have aided this rocking motion. However, closer examination and experimental archaeology have largely dismantled this romantic notion. When researchers attempted to walk large concrete replicas, they found the process incredibly risky and damaging to the statue's base. The sharp, rocking motion would have caused the delicate stone, particularly the thin bases of many moai, to fracture and chip long before reaching its destination. Moreover, many of the island's roads from the quarry are not flat but slope upward, making an upright, rocking progression even more physically implausible and dangerous. A more grounded and evidence-based theory, gaining significant traction in recent years, involves laying the moai down and moving them horizontally. This method centers on the discovery of ancient roads or causeways leading from Rano Raraku. These paths are not simple dirt tracks. Many are purposefully paved and, crucially, are concave or U-shaped in cross-section. This specific design aligns perfectly with the idea of a sled-based transport system. In this scenario, the massive statue would be carefully lowered onto a large wooden sledge. Teams of workers would then pull this sledge along the prepared path. But the real secret to moving an 80-ton load may have been in the lubrication of the track itself. Archaeologists Terry Hunt and Carl Lipo conducted experiments suggesting that the island's most abundant resource, sweet potatoes, could have been mashed into a slippery paste. By laying this paste on the concave path, the Rapa Nui could have created a slick surface that dramatically reduced friction, allowing a relatively small group of people to pull the heavy sledge. This theory turns a potential logistical nightmare into a manageable, albeit still monumental, engineering project. Further supporting the horizontal transport idea is the condition of many moai found along these ancient roads. These fallen statues are not lying randomly. They are often positioned in a way that suggests they were being transported on their backs when they were abandoned. Their bases are frequently undamaged, which would not be the case if they had toppled during a risky walking process. This physical evidence on the ground points toward a deliberate, methodical system of sledges and lubricated pathways, a sophisticated solution born from an intimate knowledge of the island's materials and topography. It reflects a society that solved its problems with practical ingenuity rather than magical thinking. Yet, even this plausible theory does not completely close the case. The exact methods of securing the statue to the sledge, the precise composition of the lubricant, and the intricate social organization required to coordinate hundreds of workers remain aspects of a lost skill set. The true method was likely a complex combination of techniques, a carefully guarded knowledge passed down through lineages of master movers. This specialized understanding vanished in the turmoil that followed the island's ecological and social collapse before European contact. The transportation of the moai stands as a powerful symbol of human determination and collective effort. It was a technology not of machines but of coordinated will, a brilliant adaptation to a specific environment that enabled a small island society to create one of the most awe-inspiring monumental landscapes on Earth, leaving behind a silent testament to a logistical genius we can only partially reconstruct. Just off the westernmost tip of Japan, in the clear, deep waters surrounding Yonaguni Island, lies a structure that challenges the very timeline of human civilization. Discovered by a local diver in 1986, the Yonaguni Monument is a colossal, layered rock formation that plunges from just 16 feet below the surface to depths of over 80 feet. What makes this site so profoundly controversial is its appearance. It looks for all the world like a grand, sunken pyramid or a terraced ziggurat, complete with what seem to be massive steps, wide platforms, sharp, 90-degree angles, and even what some describe as a ceremonial gateway and a carved face. For those who argue it is man-made, it represents the potential ruins of a lost city, a megalithic technology from an era so ancient it was swallowed by the sea over 10,000 years ago. The case for the structure being a product of human hands rests on a collection of strikingly unnatural features. Proponents, led by researchers like Professor Masaki Kimura of the University of the Ryukyus, point to the two towering pillars that stand near the main structure, which appear too precisely placed to be a natural occurrence. They highlight the triangular pool, a perfect geometrically shaped depression, and the loop road, a wide, cleanly defined pathway that seems to encircle part of the complex. The most compelling visual evidence is the sheer regularity of the terracing. The massive, stacked slabs have remarkably clean, straight edges and consistent heights, forming a grand staircase that seems deliberately carved. If this were on land, the debate would likely be less intense. Its location underwater, in an area known for seismic activity, is what places it at the furious center of archaeological controversy. The primary argument against this awe-inspiring narrative is a powerful one: geology. Skeptics, including many mainstream geologists, argue that the Yonaguni Monument is a spectacular example of natural sandstone weathering. The rock in this region is known as mudstone, and it is naturally fractured along horizontal and vertical planes due to tectonic stresses. Over millennia, the powerful ocean currents prevalent in this area have relentlessly eroded these fracture lines, scouring out the softer rock and leaving behind the harder, more resistant stone in what appear to be clean, geometric formations. This process, known as sheet jointing, can create remarkably flat surfaces and sharp angles entirely through natural means. The apparent steps are simply layers of rock eroding at different rates, and the carvings are likely just the results of marine organisms boring into the stone or the relentless scouring action of sand carried by the currents. This geological explanation, however, does not entirely silence the questions. The most challenging aspect for the purely natural theory is the presence of specific features that seem to defy random erosion. For instance, a large circular depression on the top platform matches almost perfectly with a separate rock found nearby, suggesting it could have been a deliberately placed capstone. Furthermore, while nature can create straight lines and angles, the concentration of so many perfect right angles, parallel walls, and seemingly symbolic shapes in one relatively small area gives even some geologists pause. The debate often hinges on a concept known as the smoking gun, a single, undeniable piece of evidence, like a tool mark on a surface that could not have been formed by natural forces, or an artifact found in situ within the structure. To date, no such definitive proof has been conclusively documented, leaving the mystery tantalizingly unresolved. The implications of the Yonaguni Monument being man-made are, to put it mildly, revolutionary. If human hands carved this structure, they did so at a time when conventional archaeology tells us humans were simple hunter-gatherers, barely emerging from the Paleolithic era. The last time the area where the monument sits was above water was at the end of the last ice age, around 10,000 years ago, during a period often associated with global flood myths. This would place its construction potentially older than the oldest known megalithic sites on Earth, such as Göbekli Tepe in Turkey, pushing back the clock on complex human society by thousands of years. It would suggest the existence of a sophisticated, seafaring culture in prehistoric Japan, a civilization whose entire history has been erased by rising sea levels, leaving only this solitary, enigmatic ruin as a silent witness to a forgotten chapter in human history. Ultimately, the Yonaguni Monument remains a powerful symbol of the limits of our knowledge. It sits at the frustrating and fascinating frontier between geology and archaeology, a place where the lines between natural wonder and human achievement are profoundly blurred. Whether it is a masterpiece of natural sculpture or the ghost of a lost civilization, it forces us to look at the ancient world with humility and wonder. It stands as a permanent invitation to keep exploring, to keep questioning, and to remain open to the possibility that the deep waters of our planet may still hold secrets capable of rewriting the story of humankind. Beneath the quaint villages and rolling farmlands of Central Europe lies a hidden world that has puzzled archaeologists and historians for generations. We are not talking about natural caves or medieval cellars, but a vast, enigmatic network of hand-carved tunnels known as Erdstall. These are not grand, spacious passageways. They are incredibly narrow, often no more than 2 feet in diameter, forcing a person to crawl on their hands and knees. They wind and twist for miles, sometimes featuring multiple levels, dead ends, and curious side chambers too small to stand in. Their construction is attributed to no known kingdom or civilization, and their purpose remains one of Europe's most stubborn archaeological mysteries, giving rise to legends that they are the work of a mythical, ancient race, the Hyperboreans. The name Hyperborean comes from Greek mythology, meaning beyond the north wind. The Greeks envisioned these people as a peaceful, almost divine race living in a sun-drenched land of plenty, untouched by the struggles of the ordinary world. Over centuries, as Europeans encountered mysterious ancient structures with no clear builders, the label Hyperborean was often applied as a catch-all explanation for wonders that seemed to predate recorded history. The intricate, continent-spanning tunnel systems became a prime candidate for this legendary attribution. It was easier to believe they were the work of a lost, advanced people than to accept that our understanding of early medieval Europe was simply incomplete. This mythological connection adds a layer of romantic intrigue, but the physical reality of the tunnels presents a far more tangible puzzle. The engineering challenges alone are staggering. To create these networks, builders had to dig through solid earth and rock using only the most basic tools, likely antler picks, stone hammers, and simple wooden shovels. The tunnels are not random diggings, they show evidence of careful planning. The walls are often smoothed, and the ceilings are frequently arched or keyhole-shaped, a design that provides remarkable structural stability, preventing collapse over centuries. Many tunnels include sophisticated features like vertical entrance shafts that could be sealed with a stone plug, hidden exits emerging in riverbanks or dense thickets, and intricate ventilation shafts that are almost impossible to detect from the surface. This points to a profound, accumulated knowledge of subterranean construction, a technology of survival that was passed down through generations but never written down. So why were they built? The theories are as varied as the tunnels themselves, and none offer a perfect answer. One of the most persistent ideas is that they were refuges. In an era of constant raids from Vikings, Magyars, and rival clans, these tunnels could have served as hidden shelters where entire communities, along with their precious food and livestock, could vanish from sight until the danger passed. The narrow entrances were easily defensible, and the confusing layouts would disorient any pursuer. However, the refuge theory has its flaws. The tunnels are often cramped and lack sources of fresh water or air for extended stays, and many have no storage areas large enough for significant supplies. This has led to alternative explanations rooted in spirituality. Some researchers propose the tunnels were ritual spaces, perhaps used for initiation rites or as symbolic representations of a journey to the underworld. The act of squeezing through a dark, confined passage, only to emerge into a slightly larger chamber, could have held profound religious significance. The presence of cup-marked stones and other simple carvings in some tunnels lends a small amount of credence to this idea. Another practical theory suggests they were used for storage, specifically to keep food cool and safe, but again, the extreme narrowness of most passages makes this logistically difficult. Perhaps the most compelling mystery is the sheer scale of the phenomenon. Similar tunnels have been found across a wide swath of Europe, from Germany and Austria to Ireland and Scotland. While they are often called the Erdstall tunnels in Bavaria, local traditions know them by many names, often associating them with fairies, dwarves, or other supernatural beings. This geographic spread suggests that the knowledge of how to build them, and the reason for doing so, was once widespread among the common people of early medieval Europe, not a secret held by a mythical race. Yet, this common knowledge vanished completely. By the High Middle Ages, no one was building tunnels like this anymore, and their original purpose was forgotten, even by the people living directly above them. The true technology, the specific engineering principles, the social organization required for such colossal communal projects, and the spiritual or practical imperatives that drove them, is a lost chapter in the story of human adaptation, a silent network of passages waiting beneath our feet, holding their secrets close. Yet another of Heron of Alexandria's inventions demonstrates how his genius was applied to the realm of the divine. creating moments of pure theater designed to blur the line between the mortal and the immortal. Picture yourself as a worshipper in a 1st century Alexandrian temple. You approach the altar, make an offering, and light a sacred fire. As the flames begin to rise, something miraculous happens. The massive, heavy doors of the temple's inner sanctum, without a single person touching them, slowly and majestically begin to swing open, revealing the cult statue within. To the average person, this was not an engineering marvel. It was a direct manifestation of divine power, a sign that the gods had accepted the sacrifice and were now present. This was the purpose behind Heron's automatic temple doors, a masterpiece of mechanical illusion that harnessed basic physics to create an experience of profound wonder. The mechanism, described in Heron's work Pneumatica, was a symphony of simple components working in clever concert. The entire process was triggered by the lighting of the altar fire. Hidden beneath the altar was a sealed, airtight container partially filled with water. As the fire burned, it heated the air inside this container. According to the fundamental principles of pneumatics, a science the Greeks were actively exploring, air expands when heated. With no room to expand within the rigid container, the increasing air pressure forced the water out through a pipe. This pipe acted like a siphon, channeling the displaced water into a large bucket suspended from a system of ropes and pulleys. Here, the principles shifted from pneumatics to mechanics. The bucket, now gradually filling with water, became a counterweight. As it grew heavier, it began to descend. The ropes attached to it were wound around axles connected to the temple doors. Think of it like a giant, slow-moving version of a window shade. As the weighted bucket descended, it turned the axles, which in turn unwound the ropes, pulling the doors open. The speed of this operation could be controlled by the size of the siphon and the capacity of the bucket, ensuring a dignified, unhurried reveal rather than a sudden, jarring movement. Once the ceremony was over and the altar fire died down, the air inside the container would cool and contract. This created a vacuum that reversed the process, siphoning the water back from the bucket into the original container. As the bucket emptied and became lighter, a counterweight on the other side of the pulley system would take over, slowly and smoothly drawing the doors shut once more, completing the mystical illusion. This invention is a prime example of a technology developed not for economic or practical utility, but for religious spectacle and the consolidation of priestly authority. The primary goal was to inspire awe and reinforce the belief in the temple's power. By creating a seemingly magical event, the priests could strengthen the faith and the donations of the congregation. The resources and knowledge required to build and maintain such a system were significant, but they were considered a worthwhile investment for the social and spiritual control it afforded. This context is crucial to understanding why such an ingenious application of steam power and mechanics did not lead to an industrial revolution. The value of the technology was perceived in its ability to create wonder, not in its potential to pump water or automate labor. It was a solution to a spiritual and theatrical problem, not an economic one. The fate of this knowledge is a telling chapter in the history of technology. Heron's detailed writings survived, but the specific social and religious context that gave them purpose did not. As the classical world transformed, the great temples of the old gods declined, and with them, the demand for such elaborate divine theatrics. The knowledge of how to build automatic doors became a curiosity preserved in manuscripts, an interesting footnote for later scholars rather than a living, evolving technological tradition. It was a brilliant application of principle that was never divorced from its original, narrow purpose. The automatic temple doors stand as a powerful symbol of a path not taken, a reminder that the trajectory of innovation is shaped not just by what is possible, but by what a society values enough to sustain and develop across generations. Far to the north, in the graves of Viking traders and craftsmen on the island of Gotland, archaeologists have uncovered objects that seem to defy the era's technological profile. exquisitely crafted lenses made of solid rock crystal. These are not the murky glass of later periods, but lenses ground from pure, transparent quartz, a material far harder and more difficult to work than glass. Their quality is so high that when tested, some have been found to be nearly free of optical distortion, capable of focusing light to a sharp point or magnifying objects with startling clarity. In the hands of a culture we often associate with axes and longships, these delicate instruments suggest a sophisticated understanding of light and vision that has been almost entirely overlooked. The immediate and most dramatic application for such a lens would have been as a fire starter. A skilled user could angle a crystal lens to concentrate the faint Nordic sun into a searing pinpoint of heat, igniting tinder with what would have seemed like magical ease. This would have been an invaluable tool on long sea voyages or during the dark winters, a reliable alternative to flint and steel, but the potential uses extend far beyond this simple utility. Imagine a master jeweler or metalworker in a dim longhouse, using one of these lenses to examine the minute details of a filigree pattern on a brooch or to inspect the edge of a newly forged blade. With this tool, the legendary complexity of Viking art, with its intricate animal styles and precise geometric patterns, becomes easier to understand. It would have allowed for a level of fine detail work that is difficult to achieve with the naked eye alone, elevating their craftsmanship from skilled to truly superlative. The creation of these lenses itself represents a lost technical art. Rock crystal, a form of pure quartz, is one of the hardest materials known to the ancient world, ranking just below diamond on the Mohs scale. To grind and polish it into a precise convex or concave shape without modern diamond-tipped tools would have required incredible patience, skill, and a deep empirical knowledge of abrasives. The lapidary would have likely used a combination of finer and finer sands, perhaps emery or crushed garnet, painstakingly rubbing the crystal against a softer stone or metal plate to gradually achieve the perfect curvature. The process was not merely about shaping, it was about achieving an optical quality that suggests the makers were not just artisans, but the first experimental opticians, understanding through trial and error the principles of focal length and light refraction. This is what makes the Viking lenses so hauntingly significant. They represent a technological path that was opened but never fully walked. In the hands of the Vikings, this was a technology of utility and craft, a secret held by a few specialists. There is no evidence they ever thought to combine lenses in a tube to create a telescope or to stack them for a microscope. The social and intellectual conditions for such a leap, a culture of systematic scientific inquiry that sought to see the very small or the very far, simply did not exist in the Viking world. The knowledge of how to make these superb optical instruments likely died with the master crafters, a specialized skill that was not deemed important enough to be widely taught or written down. It is a poignant reminder that an invention's potential is only realized when the surrounding culture is ready to receive it. The Vikings held the key to an optical revolution in the palm of their hand, but used it only to light a fire or adorn a treasure, leaving the greater universe of stars and cells unseen for centuries more. Descending into the Hal-Saflieni hypogeum on Malta is like stepping into the very bowels of the earth, a labyrinthine underground temple complex carved from the living rock over 5,000 years ago. This is not a natural cave system. It is a monumental feat of Neolithic engineering, a 3-level deep sanctuary of halls, chambers, and burial niches that plunges visitors into a profound primordial silence. But as you move deeper into this sacred darkness, you begin to discover that the silence here is an illusion. The hypogeum holds an acoustic secret so precise and so strange that it suggests its builders possessed an understanding of sound that borders on the magical, a lost technology of vibration and resonance designed to manipulate human consciousness itself. The most famous example of this phenomenon is found in what archaeologists call the oracle chamber. This small, circular room is unremarkable to the eye, but when a deep male voice speaks certain low frequencies into a specific niche in the wall, something extraordinary happens. The sound doesn't just echo, it undergoes a bizarre transformation. The vibration resonates through the entire chamber, amplifying and deepening until it seems to emanate from the very walls and floor, creating a sensation that is felt as much as it is heard. This effect is not a haphazard result of the chamber's shape. Modern acoustic analysis has shown that the auricle chamber acts as a perfect resonator for sounds in the range of 110 Hz, a frequency that falls within the lower register of the human voice. The architecture itself is tuned like a musical instrument to respond to and magnify this specific vibrational pitch. This leads to the most compelling and controversial theory about the hypogeum's design, that this acoustic property was not a fortunate accident, but the entire point of its construction. We are looking at a masterwork of what is now called archaeoacoustics, the study of sound in archaeological contexts. The builders, it seems, may have been pioneering neurotechnologists. Recent scientific studies have shown that exposure to sound waves at frequencies around 110 Hz can have a measurable effect on the human brain. It can suppress activity in the language centers of the left hemisphere, while simultaneously stimulating the more intuitive, creative right hemisphere. In simpler terms, this specific vibration can induce an altered state of consciousness, a trance-like condition conducive to vivid imagery, a sense of spiritual connection, and a dissolution of the ego. For a shaman or a priestess in the oracle chamber, chanting or toning at this frequency, the very architecture of the hypogeum would have acted as an amplifier for their vision quest, using physics to open a doorway to the mind's inner landscape. The staggering implication is that the Neolithic architects of Malta somehow understood these principles 5 millennia ago and possessed the technical skill to tune solid rock to achieve this effect. Without any modern sound modeling software or even a written language, how could they have accomplished this? The process would have been one of relentless empirical experimentation. It is likely that master builders, or perhaps a lineage of sound-sensitive priests, worked for generations carefully carving, testing, and then refining the contours of the chambers. They would have used their own voices and perhaps simple drums as tuning forks, listening intently to how the rock responded, and then painstakingly chipping away more stone to adjust the resonance. This was a technology of the ear and the hand, a deep, intuitive knowledge gained through centuries of patient observation and adjustment, a tradition of acoustic engineering that was passed down orally and then lost to time. The purpose of this sonic technology was almost certainly ritualistic. The hypogeum was a place of burial and communion with ancestral spirits. In the flickering torchlight of the oracle chamber, a priest's voice, transformed by the architecture into an omnipresent, bone-rattling drone, would have seemed like the voice of the earth goddess herself. The psychological impact on initiates would have been overwhelming, blurring the lines between the physical world and the spirit world, making the impossible seem real. This was not mere ceremony, it was a sophisticated tool for psychological manipulation, a way to engineer a shared spiritual experience that would bind the community together and reinforce the power of the religious hierarchy. The hypogeum stands as a silent monument to a forgotten science, a place where architecture was not just about space, but about sound, and where the ultimate technology was the mastery of the human mind itself. Hidden deep within the lush jungles and river deltas of southern Costa Rica lies a mystery carved in granite, a collection of artifacts so perfectly formed they seem to defy the capabilities of the culture that created them. These are the stone spheres of the Diquis, hundreds of almost perfectly round sculptures ranging in size from a few inches to over 8 feet in diameter, with the largest weighing an astonishing 16 tons. Discovered in the 1930s when the United Fruit Company was clearing land for banana plantations, these spheres were initially pushed aside by bulldozers, their true significance unrecognized. It was only later that archaeologists realized they were looking at the handiwork of a sophisticated pre-Columbian society, a people who had managed to achieve a level of geometric precision with stone tools that continues to baffle engineers and historians to this day. The immediate and most profound question is how such near-perfect roundness and smoothness was achieved. The spheres were carved from a hard igneous rock called granodiorite, a material far tougher than the basalt or limestone used by many other ancient cultures. The creators, who flourished from around 800 years after the Common Era right up to the Spanish conquest, had no metal tools harder than the stone itself. Their entire toolkit consisted of other stones, likely using hammerstones made of an even harder material like quartz, along with sand and water for grinding. The prevailing theory suggests a multi-stage process that required immense patience and skill. First, a large boulder would be roughly shaped into a cube by heating it with fire and then rapidly cooling it with water, causing layers to fracture away. Then the real artistry began. Workers would painstakingly peck away at the corners with hammerstones, gradually creating a faceted shape that approached a sphere. The final and most crucial stage involved endless grinding with sand and water, using a piece of leather or a coarse stone to abrade the surface in a continuous, rotating motion, slowly wearing down the high points until a breathtakingly smooth and round form emerged. The true technological secret, the one that has been lost, may not be in the tools themselves, but in the quality control process. How did these artisans ensure the sphere was truly round from every angle without modern measuring devices? Some researchers propose they may have used a simple but effective method involving strings. By suspending a cord from the top of the sphere and measuring the distance to the surface at various points, they could check for consistency. Another theory suggests they might have constructed a wooden frame or cradle that could be rotated, allowing them to systematically work on the entire surface evenly. The final polish, which gives many of the spheres an almost mirror-like sheen, was likely achieved by burnishing with fine sand or even the abrasive leaves of certain local plants over countless hours. This was not a quick process. Creating a single large sphere could have taken a team of workers many years, representing an enormous investment of communal labor and time. This immense effort naturally leads to the question of purpose. Why would a society dedicate so much energy to creating these enigmatic objects? The theories are as varied as the spheres themselves. One of the most compelling ideas is that they served as astronomical markers. Some spheres were found arranged in alignments that correspond to celestial events, such as the rising and setting of the sun during solstices or the positions of significant stars. These stone calendars would have been crucial for an agricultural society, dictating the timing of planting and harvests. However, many spheres were moved from their original positions during the 20th century, making it difficult to confirm these astronomical connections with absolute certainty. Another prominent theory posits that the spheres were powerful status symbols. Their size and perfection would have been a clear display of a chieftain's wealth, authority, and ability to command labor. Placed in prominent positions near important dwellings or along pathways, they would have communicated the power and prestige of a specific clan or ruler. This idea is supported by the fact that the largest spheres are often found near the sites of the most substantial structures. More speculative interpretations delve into the spiritual realm, suggesting the perfect spheres represented celestial bodies like the sun or moon, or were symbols of perfection and harmony, used in rituals to connect with the cosmos. Some local legends even speak of the spheres being magical objects from the god of thunder, or relics from the lost city of Atlantis, though these lack archaeological support. The greatest mystery, however, may be why the knowledge of their creation vanished so completely. With the arrival of Spanish conquistadors and the subsequent diseases and social collapse that decimated the indigenous populations, the cultural context and the specialized skills required to make the spheres were lost. The master carvers took their techniques to the grave, and the spheres were abandoned, slowly being reclaimed by the jungle. Today, they stand as silent, elegant monuments to a lost world. They challenge our assumptions about pre-Columbian societies, demonstrating a mastery of material and geometry that we are still struggling to fully comprehend. They are not merely stones, they are a permanent question mark etched in granite, asking us to reconsider the ingenuity of the ancient world and the fragile nature of human knowledge itself. Imagine a color so rare and so potent that its very presence on a piece of cloth could signify divine right and absolute power. This was not just a hue, it was a political statement, a spiritual emblem, and the ultimate status symbol of the ancient world. Tyrian purple, also known as royal purple, was a dye so extraordinarily valuable that for over a millennium, its production was a state secret, and its wear was restricted by law to the highest echelons of society: emperors, kings, and senior magistrates. To wear this color was to be visibly touched by the gods, and its story begins not in a royal court, but in the stinking vats of a Phoenician dye works with a most unglamorous source: the mucus secretions of a predatory sea snail. The primary source of this legendary dye was the Murex brandaris and a few related species, marine snails that thrived in the coastal waters of the eastern Mediterranean. The process of extracting the dye was a feat of industrial-scale biochemistry that was as revolting as it was brilliant. It began with the dangerous and difficult task of harvesting thousands of these snails from the seafloor. The creatures were then crushed, and their tiny hypobranchial glands, the organs that produce the precious secretion, were removed. These glands, along with the crushed shells and flesh, were then left to putrefy in large, sun-exposed lead or stone vats filled with salt water. This putrefaction was essential. The dye precursor in the glands is actually a clear, yellowish liquid. It is only through a complex chemical reaction with enzymes released during decay and exposure to sunlight and air that the famous color develops, slowly transforming from yellow to green to blue and finally to a deep, rich, and incredibly color-fast purple-red. The scale of this operation was staggering and speaks to a highly organized, specialized industry. To produce just a single gram of pure dye required to color the trim of a single garment, artisans needed the glands of approximately 10,000 individual snails. For a full robe, the numbers climb into the millions. The archaeological evidence of this industry is haunting. On the coast of modern-day Lebanon, the ancient Phoenician city of Tyre, which gave the dye its name, is surrounded by mounds of crushed murex shells so vast they form literal hills, testaments to centuries of production that decimated local snail populations. The smell produced by the rotting mollusk flesh was described by ancient authors as so foul and pervasive that it was considered a hallmark of a dye works town, an unpleasant but necessary byproduct of creating a substance more precious than gold. This immense labor and the sheer volume of raw materials required is what cemented Tyrian purple's astronomical value and its exclusive association with royalty. In the Roman Empire, sumptuary laws strictly regulated its use. An emperor might wear a full toga of the color, while a senator might be permitted only a narrow stripe on his garment. To usurp this privilege was tantamount to treason, a visual declaration of ambition that could cost a person their life. The color's prestige was rooted not just in its cost, but in its perceived qualities. Unlike vegetable dyes that faded quickly, Tyrian purple was remarkably lightfast and resistant to washing. A garment dyed with it would retain its vibrant, deep color for a lifetime, becoming a literal heirloom of power. Its depth was also unique. Ancient texts describe it as having the appearance of clotted blood, a dark, shimmering shade that was impossible to replicate with any other known substance. The knowledge of this intricate process, honed over 1,500 years, did not vanish overnight. Its decline was a slow unraveling tied to the fall of empires. As the Western Roman Empire collapsed, the complex trade networks and imperial funding that supported the dye industry disintegrated. The knowledge, however, persisted in the Eastern Roman or Byzantine Empire, with Constantinople remaining a center of production. The final decisive blow came with the sack of Constantinople by the forces of the Fourth Crusade in 1204, and the city's ultimate fall to the Ottoman Turks in 1453. With the destruction of the Byzantine state, the closely guarded guild secrets, the specific locations of the optimal snail beds, and the precise multi-stage fermentation and heating techniques were lost. The industrial art of producing true Tyrian purple from its natural source simply ceased to exist. In the mid-19th century, the chemical structure of the dye's main component, 6,6'-dibromondigo, was finally identified, allowing for a synthetic replica. While this modern version can match the color, it lacks the incredible depth, complexity, and color fastness of the original, which was likely the result of a cocktail of related compounds created by the unique biological process. Today, the secret of Tyrian purple stands as a powerful symbol of a different kind of loss. It was not a single object or a machine, but an entire industry, a complete chain of knowledge from biology to chemistry to large-scale production that vanished. It reminds us that technology can be as fragile as the civilization that nurtures it, and that some of the most profound losses are not of things, but of the intricate, hard-won processes that brought them into being. Now we arrive at one of the most enduring and iconic mysteries of the ancient world, a structure so monumental that it has captivated humanity for millennia, the Great Pyramid of Giza. The conventional narrative, taught for generations, is one of immense brute force. We are told that millions of multi-ton limestone blocks were quarried, dragged up ramps, and stacked with superhuman effort. But what if this story, while impressive, is fundamentally wrong? What if the pyramid's builders possessed a technological secret so elegant that it rendered the back-breaking labor of ramps and sledges completely unnecessary? This is the radical proposition of the geopolymer theory, a controversial idea that suggests the pyramids were not so much built as they were poured. The theory was first formally proposed in the 1980s by French materials scientist Joseph Davidovits. He argued that the majority of the pyramid stone blocks are not natural limestone carved from distant quarries, but a form of ancient concrete, a man-made geopolymer cast directly into wooden molds on the pyramid's rising tiers. According to Davidovits, the process would have been a sophisticated feat of chemical engineering. Workers would have quarried soft, natural limestone, but not as massive blocks. Instead, they would have crushed this soft stone into a powdery lime. This lime would then be mixed with water, clay, and a key ingredient, natron, a naturally occurring salt found in abundance in Egyptian salt lakes. This mixture, when combined with diatomaceous earth, a silica-rich fossilized algae also available in the region, would create a chemical reaction, forming a cement-like binder. The resulting slurry could be poured into molds, where it would set into a solid, rock-hard material that is chemically indistinguishable from natural limestone. The evidence put forward by Davidovits and his supporters is both microscopic and compelling. When samples from the pyramid's core blocks are examined under a microscope, they reveal features that are highly unusual for sedimentary limestone. Natural limestone, formed over millions of years at the bottom of an ocean, has a distinct, ordered crystalline structure, but Davidovits points to the presence of tiny air bubbles trapped within the pyramid stones, an artifact you would expect from a poured, agitated slurry, not from a stone that formed under immense geological pressure. Furthermore, the mineral composition shows a surprising amount of amorphous silica, along with elements like sodium and magnesium in ratios that do not match the known limestone quarries at Tura, which are traditionally cited as the source for the pyramid's fine casing stones. Perhaps most strikingly, the distribution of fossil shells within the blocks seems random and fragmented, as if they were broken during a mixing process rather than preserved in their original layered beds. This theory elegantly solves some of the most perplexing logistical puzzles of the pyramid's construction. It eliminates the need for the fabled, enormous ramps for which there is scant archaeological evidence. Hauling millions of multi-ton blocks up such ramps would have been a nightmare of engineering and labor management. Casting the blocks in place, however, would require moving only baskets of crushed powder and buckets of slurry, a task far more manageable and safer. It also explains the incredible precision of the block's fit. Instead of having to perfectly carve and lower irregular stones into a seamless joint, workers could simply pour new material against the hardened surface of the previous layer, creating a bond so tight that not even a razor blade can fit between the blocks. This method would account for the sheer speed of construction posited by some timelines, turning the project from a colossal moving operation into a continuous, on-site manufacturing process. Naturally, such a revolutionary idea faces fierce opposition from mainstream Egyptology. The primary counter-argument is geological. Opponents point to core samples drilled from the pyramids that show the same fossil content and layered structure as the natural limestone beds at nearby quarries. They argue that the supposed air bubbles could be the result of natural weathering over 4,500 years or the dissolution of softer fossil material within the stone. They also contend that no wooden molds or remnants of the proposed large-scale industrial mixing pits have ever been found at the Giza Plateau. For them, the evidence of quarrying is clear. We have the quarries themselves with cut blocks left unfinished, and we have ancient depictions of workers using copper chisels and stone pounders on rock faces. This clash of interpretations is more than just an academic debate. It represents a fundamental divide in how we view ancient capabilities. The mainstream quarrying theory portrays the Egyptians as brilliant organizers of labor and masters of simple machines. The geopolymer theory casts them as intuitive chemists and material scientists, possessing a secret formula that was perhaps lost when the pyramid-building era ended. Whether Davidovitz's theory is ultimately proven correct or not, it serves as a powerful reminder that our understanding of the past is never complete. It challenges us to look at the pyramid not just as a mountain of stone, but as a potential repository of a lost chemical technology, a secret recipe that allowed a civilization to shape stone as if it were mud, creating one of the wonders of the world with a knowledge that now seems almost alchemical in its sophistication. And now we explore a lost technology that challenges our entire understanding of ancient metallurgy, a secret forged not in the blast furnaces of Europe, but in the workshops of pre-Columbian South America. When Spanish conquistadors first arrived in what is now Ecuador, they encountered something they found utterly baffling. Local artisans were creating small, exquisite artifacts, nose rings, ear spools, and ceremonial masks that incorporated a metal the Europeans considered worthless and unworkable, platinum. To the Spanish, this heavy, silvery metal was a nuisance, an impurity that contaminated the gold they so desperately sought. They called it platina or little silver and largely discarded it. What they failed to comprehend was that the indigenous people of the region, the Latolita culture, had mastered a metallurgical technique so advanced that it would not be reinvented in Europe for another 3 centuries. The core of this mystery lies in a single, staggering physical property: platinum's incredibly high melting point. To melt platinum into a liquid state for casting, as one would with gold or copper, requires a temperature of 3,215 degrees Fahrenheit or 1,768 degrees Celsius. This is a heat far beyond the capabilities of any ancient furnace, which typically maxed out at around 2,000 degrees Fahrenheit, sufficient for copper and gold but utterly useless for platinum. Even the most advanced European metallurgists of the 18th century struggled immensely with this challenge, considering platinum unworkable until the invention of the oxyhydrogen torch in the early 19th century. So, the presence of solid, worked platinum artifacts in graves dating back over 2,000 years presents a seemingly impossible paradox. How did ancient artisans with simple tools and basic clay furnaces manage to manipulate a metal that defied the best technology of the Enlightenment? The answer is a testament to ancient ingenuity and a deep, empirical understanding of materials. The Latolita metalworkers did not try to melt the platinum. Instead, they pioneered a sophisticated process now known as sintering, or more specifically, powder metallurgy. The process began with the raw material itself. The platinum they used was not mined from veins in the earth, but gathered as tiny, naturally occurring granules from alluvial deposits in rivers, much like gold dust. These minute grains were the key. The artisans would carefully collect this platinum dust and mix it with a small amount of gold dust. This golden adhesive was the catalyst for the entire operation. The critical step involved heating the mixture in a clay crucible, using a furnace fueled by charcoal and likely enhanced by blowpipes to achieve the highest possible temperature. They were not aiming for the impossible melting point of platinum. They only needed to reach the melting point of gold, which is a far more manageable 1000 degrees Celsius. As the gold melted, it would coat the individual, still solid particles of platinum, acting as a liquid binder. Then, through a combination of sustained heat and skillful hammering, the artisans would perform a kind of metallurgical alchemy. The pressure and heat would force the gold-coated platinum particles into intimate contact, and at the atomic level, the particles would begin to bond or sinter together. The result was not a homogeneous molten alloy, but a composite material, a solid matrix of platinum grains firmly welded together by a thin film of gold. The artifacts produced by this method are marvels of subtle engineering. To the naked eye, they appear to be made of a single, gleaming white metal. But under a microscope, the truth is revealed, a complex microstructure of sintered platinum. This technique gave the objects an extraordinary durability and a unique, captivating appearance. The resulting metal was harder and more resilient than gold alone, making it ideal for prestigious items meant to last for generations. The knowledge required to execute this process consistently, the precise ratios of platinum to gold, the exact temperature control, the timing, and the hammering technique represents a level of material science that was completely unique in the ancient world. It was a technology born from generations of careful observation and experimentation, a secret passed down within guilds of master metalworkers, and then this knowledge simply vanished. The cultural disruption caused by European conquest, disease, and the suppression of indigenous traditions severed the chain of mastery. The Spanish had no interest in a metal they could not conventionally smelt, and the specialized practitioners of this art were lost to history. For centuries, these platinum artifacts sat in museum collections, often mislabeled or misunderstood, their true significance hidden. It was only with the advent of modern scanning electron microscopes and X-ray diffraction analysis in the 20th century that scientists could finally peer into the atomic structure of these objects and unravel the secret. The discovery was a shock to the archaeological community, forcing a complete reassessment of pre-Columbian technological capabilities. The ancient sintering of platinum stands as a powerful reminder that advanced technology is not always about achieving the highest temperature, but about finding an ingenious, elegant workaround, a lesson in sophistication that was lost, waiting silently in the earth to be rediscovered. And so we arrive at a civilization that turned the very sky above into a complex, flowing text, a people who mapped the cosmos with an accuracy that would not be matched in Europe for over 1,000 years. Far from the crowded cities of the Old World, the Maya of Mesoamerica developed an astronomical science of such staggering sophistication that it feels almost alien in its precision. They tracked celestial cycles across vast spans of time, predicting the movements of planets and the arrival of eclipses with a reliability that modern astronomers still admire. Yet, the tools they used to make these calculations, the physical and intellectual framework of their cosmic observations, have largely vanished, leaving behind the breathtaking results of their work but obscuring the brilliant methodology that produced them. The cornerstone of their achievement was a system of interlocking calendars of mind-boggling complexity. Unlike our single Gregorian calendar, the Maya used several cycles simultaneously. The 260-day sacred round, or Tzolk'in, woven together with the 365-day vague year, or Hob, created a 52-year calendar round that governed ceremonial and agricultural life. But for truly long-term reckoning, they devised the long count, a linear calendar that counted the days from a mythical starting point they placed in August of 3,114 years before the Common Era. This system allowed them to record historical and astronomical events with pinpoint accuracy across millennia. It was this long count that gave them the temporal framework to observe and document the slow, grand cycles of the heavens, treating time itself as a measurable, predictable force. Their observations of Venus are a prime example of their meticulousness. The Maya didn't just note the planet's appearance, they understood its complete synodic period. The 584 days it takes for Venus to return to the same position relative to the Sun and Earth, with an error of just 1 day in 500 years. They documented its movements as both the morning star and the evening star with incredible detail, recorded in surviving texts like the Dresden Codex. This was not idle stargazing, it was deeply intertwined with warfare and sovereignty. The heliacal rising of Venus after a period of invisibility was seen as a potent, often malevolent omen. Maya rulers would strategically time military campaigns and ritual bloodletting to coincide with specific phases of the Venus cycle, believing they were harnessing the power of the celestial god they associated with the planet. Their astronomy was a practical, living science that directly influenced the fate of kings and kingdoms. Perhaps their most astonishing feat was the prediction of solar eclipses. The Dresden Codex contains tables that track the cycles of the moon with such precision that the Maya could forecast when the sun, moon, and earth would align to create an eclipse. They understood the concept of the eclipse season and the repeating pattern known as the Saros cycle, a period of about 18 years and 11 days between similar eclipses. To achieve this without telescopes, they relied on a form of naked-eye astronomy that was almost certainly aided by simple yet effective observational tools. One theory suggests they used crossed sticks as a sighting device to precisely measure the positions of stars and planets against the horizon. Another compelling idea is that they used the architecture of their own cities as giant astronomical instruments. The narrow slots between towering pyramids or the alignment of specific doorways could have been designed to frame the rising or setting of a particular celestial body on a critical day, turning the entire urban landscape into a permanent stone observatory. This points to the true nature of the lost technology. It wasn't a single device, but an entire intellectual ecosystem, a culture of observation where priest astronomers meticulously recorded data on bark paper codices over generations. This long-term cumulative dataset was the key. By comparing observations recorded by their ancestors decades or even centuries earlier, they could identify patterns and cycles invisible within a single human lifetime. The framework that allowed this, the scholarly institutions, the precise glyphic writing system for recording data, the mathematical concepts like the concept of zero that enabled complex calculations, was a complete scientific methodology. When the Spanish conquistadors and missionaries arrived in the 16th and 17th centuries, they systematically burned Maya codices, viewing them as works of the devil. This destruction, combined with the collapse of the classic Maya civilization centuries earlier, shattered the chain of knowledge, the observational techniques, the nuanced interpretations of the data, and the very mindset that saw the cosmos as a predictable, mathematical system were largely erased. We are left with the results etched in stone on monuments and preserved in the few surviving codices, but the path to those results remains shrouded. The loss is not merely of facts and figures, but of a way of seeing, a scientific process that allowed a civilization without lenses or brass instruments to achieve a cosmic understanding that humbles the modern mind. The Maya remind us that technology is not always about the tools you hold in your hand, but about the disciplined, intergenerational pursuit of knowledge, a fragile intellectual tradition that, once broken, can leave us staring at the stars with wonder, but without the key to their deepest secrets. Our journey through the annals of lost technology now takes us to a city whose fate became a haunting legend, a warning whispered by ancient writers about the terrible power of the gods. On a winter night in the year 373 before the Common Era, the prosperous Greek city-state of Helike, a leading member of the powerful Achaean League, was utterly erased from the map. According to accounts from writers like Strabo and Pausanias, a massive earthquake struck the region, toppling buildings and sending panicked citizens fleeing into the streets. But the horror had only just begun. That same night, a colossal tsunami generated by the seismic upheaval surged inland from the Corinthian Gulf, engulfing the city and its surroundings. When the sun rose, Helike was gone, not merely damaged but completely submerged, sinking beneath the waters into a newly formed lagoon. For centuries, Helike became a tale, a mythic example of divine retribution, its physical reality doubted by scholars who thought the ancient reports were exaggerated allegory. That is, until the late 20th century, when archaeologists finally found it, and in doing so, uncovered evidence of a society with a sophisticated and ultimately fatal relationship with the very forces that destroyed it. The rediscovery of Helike is a story of modern scientific detective work. For decades, researchers searched in vain along the coastline of the Peloponnese, finding no trace of the lost city. The breakthrough came when they reconsidered the ancient texts. The descriptions didn't just say the city was by the sea, they specifically mentioned it sank into a lagoon, and that centuries later, its bronze statues could still be glimpsed tangled in the underwater reeds. This clue led geologists and archaeologists to look not on the current shoreline but inland, in areas that had been silted over by centuries of river deposits. By using core drilling and ground-penetrating radar, they made a stunning discovery. They found the remains of classical Greek buildings, pottery, and even those bronze statues, not on the seafloor but buried beneath several meters of soil in a coastal plain. The evidence confirmed the catastrophe. A powerful earthquake had caused a section of the coastline to liquefy and sink, after which it was inundated by the sea, creating a temporary lagoon that was later filled in by sediment from nearby rivers. The ancient stories were not myths, they were factual reports of a geological disaster. Helike was far more than just another Greek city. It was a major political and religious center, the leader of the 12-city Achaean League, and a rival to nearby Athens and Sparta in influence. Its wealth was built on trade thanks to its strategic position on the Gulf, and it was particularly renowned as the primary center for the worship of Poseidon, the god of the sea and earthquakes. The city's very identity was intertwined with the god whose domain would ultimately consume it. This connection suggests that the people of Helike possessed a deep, hard-won understanding of their volatile environment. They lived in one of the most seismically active regions in Europe, and it is almost certain that their architecture and engineering were developed specifically to withstand the tremors that were a fact of life. While we have no written records of their building codes, the archaeological evidence points to a society that had learned to build with earthquakes in mind, potentially developing techniques that were unique to the region. This is where the concept of a lost technology becomes so compelling. What specific engineering knowledge did Helike possess? The city's location, so close to the water in an earthquake zone, was not a naive mistake. It was likely a calculated risk enabled by advanced harbor works and construction methods. They may have developed sophisticated foundation systems, perhaps using layered stone and rubble to absorb seismic shocks, or wooden frameworks within their walls to provide flexibility, much like modern earthquake-resistant designs. Their harbor, crucial for their trade-based economy, was probably a marvel of ancient engineering, with breakwaters and quays designed to protect their fleet from both storms and the minor tsunamis that may have been a periodic nuisance. The technology was not in a single device, but in a complete urban planning philosophy, a collective wisdom about how to live and thrive in a beautiful but dangerous landscape, a wisdom passed down through generations of architects and builders. The catastrophic failure of these systems on that one night does not mean the knowledge was flawed. It means the event was of a magnitude that exceeded all historical experience and planning. The earthquake that struck was likely so powerful that it caused soil liquefaction on a massive scale, where the solid ground upon which the city was built instantly turned into a fluid-like slurry, swallowing structures whole. No building technique could have withstood that. The subsequent tsunami then finished the job, scouring away what remained. The tragedy is that the event was so total that it likely wiped out the very community that held the specialized knowledge. The master builders, the engineers, the planners, the entire living library of Helik's unique approach to seismic resistance perished in the disaster. When other Greek cities eventually rebuilt in the area, they did so with their own, more generalized techniques, and the specific, hard-earned innovations of Helik were lost. The story of Helik is therefore a profound lesson in the fragility of localized knowledge. It represents a technology that was not recorded in scrolls but lived in the practices of a specific community adapted to a specific place. When that community vanishes in an instant, their sophisticated understanding vanishes with them. It stands as a stark counterpart to the enduring Roman concrete or the precise gears of the Antikythera Mechanism. Helik's technology was embedded in a city's bones, and when the city died, the knowledge turned to dust. Its rediscovery gives us not a blueprint to replicate, but a ghost to contemplate, a reminder that advanced technology can be as vulnerable as the civilization that creates it, and that some of the most ingenious solutions of the ancient world now lie buried, waiting not to be copied but to be remembered. From the self-healing Roman concrete that challenges our modern engineering to the astronomical computers of ancient Greece, and from the Viking sunstones that pierced the fog to the cosmic calendars of the Maya, our journey through these 35 lost technologies reveals a tapestry of human ingenuity so rich and varied it shatters the simple story of linear progress. We have encountered masters of materials science who manipulated metal at the nanoscale and forged platinum without fire, brilliant mechanical minds who built steam engines and automatons for wonder rather than work, and navigators who charted the largest ocean on Earth using the subtle language of the waves and stars. This is not a history of primitive steps, but one of breathtaking peaks, summits of achievement that were reached, and then, for a multitude of reasons, abandoned and forgotten. A haunting theme connects these disparate marvels, the profound fragility of knowledge itself. In some cases, like the secret of Greek fire or the techniques of the Benin bronze casters, the loss was deliberate, erased by conquest or suppressed to maintain power. In others, like the precise art of Stradivarius or the guild secrets of the Damascus steel smiths, the knowledge vanished because the master artisans took their unwritten formulas to the grave, a living library lost when its last keeper passed away. And in still others, like the societal collapse that silenced the builders of the Moai or the cataclysm that swallowed the seismic wisdom of Helik, entire cultures and their accumulated understanding were simply wiped from the map. Civilizations are not monolithic, they are living, breathing entities, and when they fall, they can take their greatest secrets with them, leaving behind only silent, enigmatic clues. These mysteries do more than just fill us with wonder, they actively push the boundaries of our historical understanding. Each one is a puzzle piece that refuses to fit neatly into the picture we thought we had. The Antikythera Mechanism forces us to rewrite the history of mechanics. The Iron Pillar of Delhi challenges our assumptions about metallurgy. The Nazca Lines and the Plain of Jars compel us to reconsider the social organization and spiritual drive of ancient peoples. They are permanent question marks, urging archaeologists, scientists, and historians to remain humble, to keep questioning, and to be open to the possibility that the past was far more complex, sophisticated, and interconnected than our textbooks have ever allowed. And so we leave you with a question to ponder, one that stretches the imagination across the centuries. Which of these lost technologies do you find the most astonishing? Is it the potentially revolutionary geopolymer concrete of the pyramids, the biological mastery behind Tyrian purple, or the acoustic mine temple of the hypogeum? And more profoundly, let your mind wander down the paths not taken. What might our world look like today if this knowledge had flowed in an unbroken river from the ancients to us? If the steam engine of Heron had been developed rather than dismissed as a toy, if the precise optics of the Vikings had been combined into telescopes, if the pharmaceutical knowledge of indigenous healers had been preserved and studied. The loss is immense, but the rediscovery of these ideas, even fragmentarily, gives us hope. It reminds us that human creativity is boundless and that the quest to reclaim these lost wonders is, in itself, one of the most exciting adventures of our time. We would love to hear your thoughts. Which lost technology captivates you the most? Share your ideas in the comments below. And if you enjoyed this journey into the shadows of history, be sure to subscribe for more explorations into the world's great